Hello, hello. Good evening, everyone. We'll wait for a few more minutes to start our discussion. Our life will act like a sinusoid oscillating signal. That is the reason that build up today. Background. Oscillating type. Well, yesterday we started that DTFT topic, discrete time, Fourier transform. Let us make a review what we learned yesterday. The definition of DTFT we selected as what, sir? Sigma minus infinity to infinity xn multiplied by exponential. And the inverse DTFT we studied as 1 over 2 pi integral minus pi to pi x e power j omega e power j omega and d omega. That is inverse for it. And we also mentioned it is obeying the periodicity property. Our spectrum periodically repeats for every 2 pi. X of e power j omega plus 2 pi k equals to x e power j. For the first problem only we have drawn the spectrum. Today we are going to discuss for some more models. Try to draw the spectrum for the range minus pi to pi. After that, make periodic repetition. Try to draw the shape of the spectrum for the range minus pi to pi. After that, periodic repetition. Okay. See, the lowest frequency 0, highest frequency is pi. Lowest frequency 0, highest frequencies. The last observation we have made is on scaling, sir. Time scaling property. That is the last observation we have made. Let us go to the next property. Differentiation property. Differentiation property. We studied differentiation with respect to one variable corresponds to multiplication by other variable. That is the point we studied, sir. Differentiation with respect to one variable corresponds to multiplication by. And one more point we mentioned is to convert Laplace to Fourier with respect to properties. What is the mathematical change, sir? S place j omega. In a similar way, this topic to next topic. This topic to next topic means z is replaced as e power j omega. Let me compare differentiation property in all forms. First, everyone listen carefully, sir. Differentiation property in all forms. Recollect, d by dt xt means what we have written in CTFT. For d by dt, we said the multiplier is j omega or not. Same thing in Laplace, we replaced as s into xs. For d by dt, j omega, s into x. When you take differentiation in continuous case, discrete case, it is treated as a difference. When you take differentiation word, discrete case, it is treated as difference. Xn minus x of n minus 1. Differentiation converted to difference means, now what is the DTFT answer, sir? 1 minus e power minus j omega of original spectrum. 1 minus e power. Whereas in Z domain, what is the modification? Coming topic, what is the modification, sir? E power j omega plus z. See the cursor, everyone. E power j omega plus z means 1 minus z inverse. 1 minus. So this is a time domain differentiation. Left side properties are time domain difference. What is transform domain differentiation? What is transform domain? D by d omega we studied as minus jt. D by d omega in CTFT we studied as minus. By dragging that j in the denominator, j omega place we substituted yes or not. By dragging that j in the denominator, j omega place we substituted yes. In DTFT also, d by d omega is replaced as minus jn. Like in CTFT we have written minus jt, sir. In DTFT it is minus jn. If you want, you can check from the original definition. Everyone see the cursor? If I differentiate the spectrum with respect to omega, if I differentiate our definition with respect to omega, it is differentiation of exponential with omega. Automatically minus jn is the multiplier or not, sir? Minus j. In Z transform, this becomes minus z into d by dz. In Z transform, it becomes minus z into d by. Let me give that clarity also. We know z is e power j omega means what is dz term, sir? J e power j omega d omega, which is nothing but jz d omega, from which d omega can be simplified as dz by jz. directly in the denominator d omega place you substitute dz by jz, sir. If you substitute d omega place dz by jz, jz will go to numerator, jj cancellation, we got this property or not. So all left side terms are what here? See the cursor. All left side terms are time domain differentiation or difference. Right side are transform domain differentiation. That is what theoretically we learned as differentiation with respect to one variable is multiply by other variable. Correct or not? Differentiation with respect to one variable is multiply by other variable. Everyone go through the properties once. Go through the properties once. Differentiation with respect to one variable is multiply by other variable. Differentiation with respect to one variable corresponds to multiplication by other variable. Everyone must be thorough with CTFT relations. Please refer my review notes. My handwritten notes, I think it is also uploaded. The last page is review notes for everyone. In that last page only, I have done the comparison of all properties. In the review notes, my handwritten notes are, which is uploaded. The last page is comparison of the relations only, comparison with respect to properties. How to make CTFT to Laplace, DTFT to jet transform, that conversion we discussed. Try to observe that. I think regularly they are uploading class notes na. In that only it is there. The site. They are uploading the class notes, so there only it is there. Observe that files. Let us discuss one simple question on these properties. What is the Fourier transform of n into a power n un, we can say? What is the Fourier transform of n into a power n un? According to our yesterday's discussion, what is the known signals are? The first formula we discussed is a power n un spectrum or not? A power n. What is the spectrum of a power n un we have written? 1 by 1 minus a e power minus j omega. A power n un spectrum is 1 by 1 minus multiplied by n means other domain differentiation. Multiplied by n means other domain. Apply frequency differentiation and check your result. Try to apply frequency differentiation property and observe the spectrum. Come on. Review notes means only important formulas to remember. Whatever I give on the slides, it will not be available. What to remember in each chapter? Yesterday's two problems, how they will be there. Review means what to remember. You will by heart all that numbers, sir. That is different, sir. Review means conclusion of every topic, what to remember in each topic. Like this. Like this. So when you apply frequency differentiation for n, what is the multiplier, sir? If I multiply the property both sides by j, j into d by d omega. For n, the replacement j into d by d omega, original spectrum 1 by 1 minus a e power minus j omega. Just to simplify, it becomes a e power minus j omega by 1 minus a e power minus j omega whole square. It will appear like d by dx of 1 by xr. Do that simplification, minus 1 by x square. After simplification, that will be the result. Multiplied by n means other domain differentiation. Application of frequency differentiation property here. This is not a new concept. In CTFT also what we have done first, t times e power minus at ut. Just recollect, sir, those who have studied that chapter thoroughly. T times e power minus at ut means we applied frequency differentiation only there also. Now I have given that as n into a power n un. N into a power n un. Based on this relation, one simple question for you, sir. Based on this relation, what is the value of sigma 0 to infinity n into 1 by 3 whole power n? What is the meaning of sigma, sir? Area under the signal appearance or not? Based on the previous slide, n into a power n un, we want area under the signal. Because it is multiplied by un, I started summation from 0 to infinity. If you want area under the signal, where you have to take spectrum? Respond everyone. Area under the signal corresponds to checking spectrum at origin or not. What happens if I substitute omega place 0 here? What happens if I substitute omega place 0? A by 1 minus a whole square. A by 1 minus a whole square. What is that a number given, sir? 1 by 3 by 1 minus 1 by 3. This is like area under the signal. Area under the, take the spectrum at origin. Summation meaning is area under the signal, take the spectrum at origin, sir. Area under the signal corresponds to checking spectrum at origin. In the formula, we got omega place 0, a by 1 minus a whole square. What is that a number for us? 1 by 3. 1 by 3 by 1 minus 1 by 3 whole square. Good, good. Think about this right-sided question. Think about the right side question, sir. Find the Fourier transform of n into e power jn pi by 8 alpha power n minus 3 u of n minus 3. What is the known signal for us, sir? Neatly. Alpha power n un is the known signal. Alpha power n un is the known signal. Just check which properties to be applied there for getting the result. Check which properties to be applied there. As the known formula is alpha power n un, the first property which we are applying is a time shifting, sir. Alpha power n minus 3 u of n minus 3. Later on multiplied by exponential. Any signal multiplied by exponential term means immediately frequency means other domain. What will happen? Differentiation. 3 properties we should apply here. Alpha power n un is the known signal shifted by 3 samples. First time shifting. For that new signal, you are treating that as a new signal multiplied by exponential means frequency shift. Later on n means frequency differentiation. Application of 3 properties will give us the result. Application of 3 properties. Think. See here, I am writing the result directly. First alpha power n un means, what is the answer? 1 by 1 minus alpha e power minus j omega. First alpha power and un, sir. 1 by 1 minus alpha e power. As it is shifted by 3 samples, e power minus j omega n naught. Our n naught number 3, sir. As it is shifted by 3 samples. As it is shifted by 3 samples, e power minus j omega n naught. First application of time shifting is over. Later on, it is multiplied by exponential, means modulation property comes into picture. Xn into e power j omega cn means x of e power j omega minus omega c form. Modulation property. So whatever the spectrum we got, there omega c number is what? Pi by 8. Omega c number is, just to show variation, I am writing with another color pen. In the spectrum answer, you got omega place, you substitute omega minus pi by 8. In the spectrum, after application of time shifting property, whatever the spectrum you got, it must be shifted by pi by 8 units. It must be shifted by pi by 8 units. Finally, for n multiplier means we know it is frequency differentiation. N multiplier means we know it is frequency differentiation, j into d by d omega. Don't do the differentiation. Just we are checking application of properties here, sir. Don't do the differentiation. We are checking only application of properties. First alpha power in un means 1 by 1 minus alpha e power minus j omega. As it is shifted by 3 samples, e power minus j omega and not that quantity over. That is extra multiplied by exponential means frequency shifting. Later on n multiplier means j into d by d omega. Later on n multiplier means j into d by d. Continuous case we studied. When you convolve e power minus at ut with itself, what is the Fourier transform answer we have written, sir? 1 by a plus, and of course we know the time domain function answer as what? T e power minus at ut. In a similar way, what is the decaying exponential style here? A power n un convolved with a power n un. A power n un convolved with a power n un means spectrum is 1 by 1 minus a e power minus j omega whole square. There we got answer as a t e power minus at ut. Now what is the change in the answer? There we got t e power minus at ut. What is the change in the answer? Come on, friends. Writing not visible. Yes, sir. For everyone, it is not visible. Whatever I am writing, it is not visible. What, Mr. Hemant? Now you are saying it is okay. Acha, what happened? Maybe certain amount of delay, page delay or group delay that we have to calculate. Acha, there is certain amount of delay, sir. I don't know why that problem is there. Okay. The answer is n plus 1. Some of you have answered very good. N plus 1 into a power n un. Don't feel n into a power n un. That is wrong. Because from our previous slide, n into a power n un spectrum contains numerator as what, sir? N into a power n un spectrum contains a e power minus j omega. But what is the numerator now? 1. This is not a big deal. We studied in convolution. Ut convolved ut is r of t, t into ut. Ut convolved ut is r of t, t into ut. Discrete case, un convolved un is n plus 1 into un. Un convolved un is n plus 1 into. If you want to see the correctness of this formula, sir, nothing is there. N into a power n un one term, a power n un another term. Just add spectrum of both the signals 100%. This is the answer. N into a power n un is available in the previous slide. This spectrum. A power n un standard 1 by 1 minus a e power minus j omega. Add the spectrums 100%. This will be the answer. Okay. My signal got delayed by some amount as we are learning signals and system. Okay. So now you can understand the concept of group delay easily. Yes. That numerator a e power minus j omega we got after differentiation, sir, due to frequency differentiation. This is t e power minus a t ut. This is n plus 1 into a power n un. Don't mix them. As t e power minus a t ut is there, don't write here as n into a power n un. Let us make a conclusion on this convolution also. Convolution property also. Let us make a conclusion. First, you listen here. What is that conclusion is? We are treating the given system as LTA system always, linear time. That is denoted as h of t, continuous case, output y of t, input. What is the equivalent change in discrete case, sir? Black box is denoted as hn, impulse response, input xn, output yn. Input xn, output yn. How we discussed the frequency response definition in Fourier transform, y omega by x omega is called as frequency response, output Fourier transform by input. If you know frequency response, you are getting impulse response answer. How we discussed the same thing in Laplace domain, sir. H of s equals to ys by x of s. This is called as a transfer function. What is the inverse Laplace of transfer function? That is also called as impulse response. But what is the enjoyment now? In the case of discrete system, how we are going to denote frequency response with a symbol h e power j omega. H e power, that is nothing but y e power j omega divided by x e power. Once you take inverse now, if you take inverse now, it is retaining impulse response for us. Z domain, what we'll call same thing, transfer function. That is yz by x of z. So the inverse z transform is what? Impulse response. Certain times in Laplace domain, yesterday we solved a differential equation. System is mentioned as a differential equation. Their differential equation means what that fellow will give here? Difference equation. Entire signal subject, this is the build-up. Input known, system known, get the output, or input known, output known, get the system. So what is the technique? Fourier domain, the system response is called as frequency response. Laplace and Z domain, It is called as system function or transfer function. Laplace and Z domain, what is the name, sir? Transfer function. But Fourier domain, it is called as frequency response. So if you want to get impulse response, there are two techniques. From frequency response we'll get our transfer function. Here also from frequency response we'll get our transfer. Suppose differential equation is given and asked for h of t. What do you have to do? Fourier transform of output by input or Laplace of output by input. There is a logic or not? So this is what convolution property mainly indicates for us. Convolution property. In any problem, it is asked for impulse response means there are two techniques for getting the results here. What are the two techniques? Solve for frequency response, or solve for transfer function. Solve for frequency response or solve for transfer function. We are going to get the result. I hope every one of you will answer the right side question. Even today you are not answering means it is shame on you. Last 5-6 days, at least 10 to 15 such models we solved. Come on friends, it is a challenge for you. Very simple question, please answer me. Right side example. Input is sum of sine and cos. System is SAP function. What is the output? Come on, come on. Sin pi n by 8 minus 2 cos pi n by 4. What is our system? Every one of us know it is an ideal low pass filter or not. What frequency range it is covering, sir? Minus pi by 6 to ideal low pass filter. So this filter can pass only which term? First term. So output answer is what? Sin pi n by 8. Continuous case also we solved this type of model or not? Continuous case also we solved this type of model. This is not the first time we are solving this question, sir. Very good. Most of you answered. Very good. Input sinusoidal means output is also sinusoidal. The given system now acting like what? An ideal low pass filter. Given system is ideal low pass filter. Okay, moving to the next one, next concept. This is the next model asked, sir. An LTI system is aims at an impulse response which is defined for total 4 samples plus or minus 2 and plus or minus 1. Find the output when you apply input as e power jn pi by 4, which is simply our eigenfunction logic. It is simply eigenfunction logic. Just recollect what is the output due to an eigenfunction contains a eigenfunction itself extra multiplied by eigenvalue. Eigenfunction itself extra multiplied by, once for all I am generalizing. See here everyone. If you apply e power j omega t, the output we have written as e power j omega t into h omega. extra scaling factor eigenvalue in Fourier domain, it is called as frequency response. Laplace domain, yesterday also we used it in one example. Input e power st, output is e power st into h of s transfer function. Now discrete case, we are denoting input as e power j omega naught n. Output is e power j omega naught n into h of e power z transform z power n means z power n into hz. Whenever the input and output forms are looking like same, we are treating them as eigenfunctions or not. So which are 100% eigenfunctions for us? Complex sinusoids and complex exponential. These two are complex sinusoid. E power st, z power n, they are complex exponential. They are treated as eigenfunction. How we define eigenfunctions are? Come on. How we define eigenfunction? Whenever the input and output answers are same, that is treated as eigenfunction. So to solve this problem, which logic you are applying? This logic. Input e power j omega naught n, output is e power j omega naught n into h of e power. Half answer I will give. Output should contain again input means e power j n pi by 4, it will be there. Half answer. You tell me what is that extra multiplying factor. You tell me what is the extra multiplying factor, sir. As impulse response is known for you, this is impulse response. By applying Fourier transform, what you have to calculate first, sir? Frequency response. Then later on omega place pi by 4. Calculate frequency response by using DTFT definition. Tell me what is the extra multiplier. Good. One fellow has given positive response till now. Very good. Tell me what is the extra multiplier. Calculate the frequency response. Calculate the frequency response first. Later on, omega place substitute the input frequency, sir. Substitute the normal definition of frequency response is sigma minus infinity to plus infinity hn e power minus j omega n. But now that answer is neatly valid only for how many samples? Plus or minus 2, and if I am substituting plus or minus 2, hn is 4 root 2 e power minus j omega into 2 plus e power minus j omega into minus 2, sir. I substituted first time n value plus or minus 2. Later on, minus 2 root 2 e power minus j omega into 1 plus e power minus j omega into minus 1. That can be written as 8 root 2 cos 2 omega. This is like cos function, sir. Minus 4 root 2. Where we are checking frequency response now. What is the input frequency given, sir? Pi by substitute here. Omega place pi by 4 means here cos pi by 2 jump minus 4 root 2 into 1 by root 2 means scaling factor is minus 4. So when the input is e power jn pi by 4, the equivalent output is what, sir? Minus 4 times e power jn. Scaling factor frequency response we got as minus 4, sir. Scaling factor. The fellows who are having my notes without asking the question only, they have typed the next one. In the same problem, I use it to give one more input. Don't get emotion. Concentrate karo subject mein. Whatever the Xerox notes that is available, it must be available in your chip, not on the paper, bachas. Before asking only, they are giving answer means they are available with notes, which is not useful for you. Concentrate on the subject. Don't get emotion. So simple thing is, as we know, impulse response, first we have to calculate frequency response. Directly substitute the input frequency. Omega pi by 4 means cos pi by 2 0. Here cos pi by 4 is 1 by root 2. Minus 4 is the scaling factor. How it is assumed as eigen. Array, build up fellow. E power j omega not 10. We proved into so many chapters. Complex sinusoids and complex exponentials are eigenfunctions of LTI system. आज भी पूछ रहे. What you have studied, bacha? Convolution, we used that Fourier series, we used Fourier transform also, we used yesterday also I used this e power st into HFS. पढ़ो अच्छे से पढ़ो पहले. Like e power j omega t, here we have e power j omega naught n. That is what I am saying. Complex sinusoids and exponentials are 100% eigenfunctions of LTI system. If I change the input as minus 1 whole power n in this problem, now you respond. According to our yesterday's discussion, to get minus 1 scaling factor, what is the frequency? How to write minus 1 in terms of exponential? Come on, friends. How to write minus 1 in terms of exponential? It can be written as e power j n pi or not. It can be written as e power j n pi. So output becomes what? E power j n pi into, check the spectrum at omega equals to pi. Check the spectrum at omega equals to pi. Respond. If I replace omega as pi, cos 2 pi 1, cos pi minus 1, cos 2 pi 1, cos pi, that becomes 12 root 2 into minus 1 whole power n. Minus 1 can be adjusted as e power j pi. Minus 1 can be adjusted as e power. Again, it is looking like complex sinusoid only. E power j omega naught n forms are. Good. Very good. Funny thing is, previous problem is input sinusoid, output sinusoid. This problem is what? Input exponential, output exponential. You see, Laplace yesterday's last 1.5 hour discussion we have done. Yesterday's last 1.5 hour. Input a cos omega naught t plus theta given to transfer function. What is the output? 5-6 models we solved. This relation also we used or not, sir? Everyone see here, see the cursor. Input e power st, output e power st into HFS. Our life is sinusoids and exponentials only. The only difference in the chapter is what? Omega has a limited range, minus pi to pi. After that, it is periodic repetition. Omega has a limited range or not? After that, it is periodic repetition. Okay. Input sinusoid to LTI system will guarantee sinusoidal output. Input is exponential means output is also exponential. Every spectrum is periodic spectrum only, bacha. Minus pi by 6 to pi by 6 we have drawn here. But our range is what? Minus pi to pi. You add another 2 pi minus pi by 6 to 2 pi plus pi by 6 will be also there. It is repeated. You are going to repeat the information. That is what we said now. If you take discrete signals, spectrum is periodically repeating. Discrete in one domain will cause periodic nature in other domain. Discrete in one domain will cause periodic nature in. Think about this question. For each of the following pairs of signal, determine whether or not the system is LTA. Determine whether or not system is LTA. Input and output combinations are given. We should decide whether it is LTA or not. First one, 1/2 whole power n un signal is there, sir. 1/2 whole power n un. I think by division is missing there. That has become 1/4 whole power n un. So whether this input output combination can be LTA or not means we can't say, because yn equals to square of the first signal. It is looking like square of the input or not. 1/2 whole square is 1/4. 1/2 whole square is 1/. So first one is not LTA. Square is linear operation or non-linear. Square operation is there means linear or non-linear. So first one need not be an LTA system. Because if I take square of the input, it is producing the output as 1/4 whole power n un. Very good. Second one, no problem. LTI system, just now we checked similar model. Input exponential, output also exponential. We checked. Second combination is LTI system, but the frequency response is not unique, sir. It is not a unique solution. Why I am saying it is not unique, just observe here. If I am taking that system as ideal low pass filter which covers from -π/3 to π/3, that is neatly passing that frequency. Of course, to be specific, 0.5 is the scaling factor, 0.5 is the amplitude. I can take the same system as ideal high pass filter also. I can take the same system as ideal high pass filter, which is having some range like π/6 to π. Still it can pass our frequency or not. Means 100% it is an LTI system, but frequency response is not unique. You can take low pass, high pass, band pass or band stop filter. Any type of filter you can take, which can pass that input frequency. 100% it is LTI, but frequency response solution is not unique. I may choose ideal low pass, another fellow may choose ideal high pass filter which can pass that frequency, or band pass filter also you can choose. Means you can have different combination of filters. You can have different combination of filters. Think about the last bit, sir. Think about the last bit. Good. Very good. Third one cannot be an LTI system because what is the spectrum of the input, sir? -π/4 to π/4 it covers. Output spectrum is what? It is limited for the range -π/2 to. How output contains more frequencies than the input? Input has maximum frequency of π/4, but still it has π/4 to π/2 range. We neatly stated LTI system cannot generate new frequencies or not. LTI system cannot generate. If input contains, it may pass or suppress, but it cannot generate new frequencies. Input is band limited for the range pi by 4, but output has still pi by 2 means no chance. No chance. If pi by 2 present at the input side, it may pass. System, this black box cannot generate new frequencies. I am expecting one MSQ on this type of things this year. Out of the 4 options given, which are maybe guaranteed as LTA, A, B or CD like that. Okay. So first one, second, last one, no chance of LTA nature, sir. No chance. In the second bit, we can choose any type of filter that can pass our frequency pi by 4. 2 examples I have shown. It may be low pass, high pass, band stop, which is having chance of passing that frequency. Means frequency response solution is not unique. You may get the outputs, sir, but solution of frequency response means different forms of filters you can take in the second case. Please answer me this question, sir. Think and answer me. Design a 3-point FIR filter, finite impulse response filter. FIR, finite impulse, and the amplitude response blocks the frequency 1/3 and passes the frequency 1/8 with unity gain. What is the DC gain of the filter? Frequency converter means modulator only, na bacha. Modulator is a variant system, already we know. Then why are you asking the question again? What is the given information? I will tell you. H of n is alpha, beta, alpha. Arrow mark indicates sample 0 means we have 3 samples, -1, 0, 1. Amplitude response means frequency blocking the frequency. What is the meaning of blocking word? At that frequency, amplitude becomes 0. At that frequency, amplitude becomes, and it is passing the frequency omega equals to 2 pi f arm, sir. It is passing the frequency 1/8 with unity gain. He wants the DC gain. DC gain means what is the DC response? H e power j0. Why these 2 points are given in the problem is, why these 2 points are given in the problem? How many unknown values are there? Alpha, beta. For calculation of alpha, beta, this information is given for us, sir. Everyone calculate first frequency response and substitute, then you will know alpha, beta. Calculate frequency response first, sir. Solve for alpha, beta, everyone. What is alpha beta? Come on. Anyone? Plus or minus 1? Ah. 1 by 1 plus root 2. Very good. That is correct. Very good. Fourier transform of impulse response is called as frequency response. So calculate h e power j omega first. Sigma hn e power minus j omega n. But what is the range of hn samples there? What is the range? Minus 1 to 1. It has only 3 samples. What is the amplitude level at plus or minus 1? Alpha. E power minus j omega into 1 plus e power minus j omega into sample at 0 is beta. That answer becomes 2 alpha cos omega plus, that is a frequency response. Substitute in the known conditions. 2 alpha cos 2 pi by 3 plus beta equals to 0. That is one condition given. Substitute directly omega place 2 pi by 3, sir. Cos 120 minus 1 by 2, from which you can say simply alpha equals to beta, sir. Cos 120 minus 1 by alpha equals to beta. Second one, 2 alpha cos pi by 4 plus beta equals to 1. It means root 2 alpha plus alpha equals to 1 as they are equal. As they are. So 1 by 1 plus root 2. 1 by 1 plus. So what is the DC gain answer? If you replace omega 0, 2 alpha plus beta means simply 3 alpha. 3 by 1 plus root 2. 3 by 1 plus root 2. Good. Very good. What is the high frequency gain in the same question, sir? High frequency gain means what is the highest frequency? Discrete case. Omega plus pi. 2 alpha cos pi plus beta. 2 alpha cos pi plus beta, it becomes minus alpha or not? 2 alpha cos pi plus beta. Minus alpha. Let us discuss few examples on filters. How to decide the nature of the filter? Let us solve few examples. Suppose the input and output are described by this simple difference equation. Yn equals to xn minus x of n minus 1. We should tell it is acting like a which filter? Is it low pass, high pass, band stop? What is the nature of the filter? We have taken xn minus x of n minus 1. It is acting like which filter? Good. Most of you are given correct answer. It is a high pass filter. Just to recollect, continuous case we studied d by dt xt, differentiator as high pass system or not, d by dt xt. First differentiation converted to first difference means it is also high pass. First differentiation converted to first difference means it is also high pass system, sir. See here everyone. Generally, to know filter characteristics, we have to sketch magnitude and phase response. Generally, to know filter characteristics, we have to sketch magnitude and. So what is the Fourier transform of this expression? Y e power j omega equals to 1 minus e power minus j omega into x of e power j omega. It means the frequency response of the system is Fourier transform of output divided by Fourier transform of 1 minus e power minus j omega. Fourier transform of output by digital or discrete case. What is the range of frequency we are varying? Minus pi to pi. Draw the spectrum for positive range. We know how to draw it for negative range. I am checking few frequencies here. I am checking few frequencies here, sir. Omega 0 means e power j01, 1 minus 1, 0. Omega pi by 2 means e power minus j pi by 2. That is 1 plus j. E power minus j pi by 2 is minus j. Magnitude root 2 angle 45 convert to polar. Root 1 square plus 1 square tan inverse. Omega pi means 1 minus of minus 1 2. So if you draw the magnitude response curve now, roughly the graph will appear like this. Roughly the graph will appear like this. This is mod h e power j omega curve. So starting frequency 0, ending frequency maximum means it is treated as a high pass system or not. Starting frequency magnitude level 0, ending frequency maximum means it is treated as high pass. Without all this mathematical build-up, what is the simple logic? Differentiator is a high pass filter. Differentiation converted to difference. So it is also high pass filter. Differentiation converted to difference. So it is also high pass filter. If I ask the magnitude and phase response separately in the frequency response answer, if I ask for magnitude and phase separately, how to solve it? Everyone see here. Whenever exponential term is there, yesterday starting only discussed, see the possibility of converting the two cos or sine function. If I am taking half frequency common, sir. If I am taking half frequency common, to get 1, it becomes e power j omega by 2 minus e power minus j omega by 2. I am taking half frequency common in the exponential. Adjustment of 2j. Adjustment of 2j, it becomes sine term or not. So 2j sine omega by 2 e power minus j omega by 2. So what is the magnitude of this quantity? Modulus of 2 sine omega by 2. Mod j1, mod exponential also 1, sir. So this is called as magnitude response. Magnitude response. What about the phase angle theta of omega? Phase response. In e power j theta, phase angle is minus omega by 2 j. Extra j multiplier is there means 90 degrees. That is phase response. In e power j theta, phase angle minus omega by 2. Extra j due to j component phase angle is 90 degrees. Frequency response itself is combination of two terms. What are they? Magnitude and phase response. Frequency response itself is combination of two terms. Magnitude and phase response. What happens if I take plus sign in the middle? What happens if I take plus sign in the middle? Xn plus x of n minus. Why I have taken extra pi by 2 means due to j, imaginary term, what is the phase angle due to plus j, plus 90. That is the reason I added pi by 2 extra. If you are going to take same expression like xn plus x of n minus 1, if you take same expression like x of n plus x of n minus 1, it is going to act like a low pass filter, middle plus sign. See the previous slide only. Middle plus sign means 2 root 2 0, starting more, ending less. Starting more, ending less. So it is going to act like which filter, sir? Low pass filter. If you draw the magnitude response graph, roughly the shape will appear like this. At 0 peak, magnitude at pi it is tending to, nothing is there, sir. Middle plus sign you take 2 root 2 0, 2 root 2 0 are the magnitude levels that will appear like this. Low pass system. Instead of yn xn, suppose I have given impulse response expression like this. Del n minus sa function. Del n minus sa function. Now you think and answer me. Del n minus sa function is given. It is going to act like which filter now? I am getting different answers. Come on, come on. It is an ideal high pass filter. What is the Fourier transform of impulse? Impulse Fourier transform is 1. Sa function spectrum is what, sir? A rectangle that covers from minus pi by 4 to pi by 4. Rectangle that covers from, after subtraction, resultant spectrum is covering only which range? Pi by 4 to pi range. Resultant spectrum is covering only pi by 4 to, that is ideal high pass system. Practical filter will have a curvature like this. Ideal system constant magnitude. That is not a big deal. Impulse is all pass filter. Sa spectrum, this we know as low pass. All pass minus low pass is high pass. This is all pass system minus low pass, that becomes high pass there. Ideal. Impulse is all pass, sa function is low pass, overall becomes ideal high pass. If I give impulse response as del n minus del of n minus 4. Now you think and answer me. Del n minus del of n minus 4. Which system? Everyone tell me, what is the Fourier transform we are going to write for this, sir? Impulse means 1. Delayed impulse means e power minus j omega n naught. Impulse means 1. Delayed impulse means e power. Check at starting and ending frequency. Check at starting and ending frequency. Omega plus 0 means 1 minus 1, 0. Omega plus pi also 1 minus 1, 0. Starting 0, ending 0 means it is a band pass filter. In between it may pass some of the frequencies, don't bother. Here our target is knowing the nature of the filter. Starting 0, ending 0 means 100% it is band pass system. What frequencies it can pass means you should check like pi by 4, pi by 2, 3 pi by 4 like that. Because in the exponential 4 omega is there. No need. Here our target is deciding the nature of the filter. Starting 0, ending 0 means it is a band pass system. Suppose I have given impulse response like this, sir. Del n plus del of n minus 2. Del of n plus del of n minus 2. Now you think and answer me. Del n plus del of n minus 2. Del of n plus del of n minus 2. Band stop filter means till pi it can pass the frequencies. One girl is asking why the previous cannot be band stop. Band stop means it can pass even the higher frequency also. Some of the middle frequencies are stopped. What is the Fourier transform of this expression, sir? 1 plus e power minus j2 omega. Tell me the answer at starting and ending frequency here. Starting 1 plus 1, 2. Ending 1 plus e power minus j2 pi. That is also starting to ending to means chance of stopping one of the middle frequency. Suppose I have chosen pi by 2, sir. Omega plus pi by 2. 1 plus e power minus j pi, that is 0 or not. So if you draw the magnitude response curve, roughly the shape is like this. Starting ending same, middle it is stopping pi by 2. Band stop or band reject filter. Band stop or band reject filter. All passa, keep it in your pocket. Oh, one fellow is giving me option also. All pass or band stop. You say all combinations ABCD, my friend. It is a band stop filter. Actually, this expression is called as comb filter in audio signal processing. It has an application. Jet transform, I will tell you the application. When I am discussing the property, I will tell you the application. Because when you draw the magnitude response curve, starting ending 0, it is passing some of the frequencies. Some frequencies are passed. Okay. So roughly its appearance is like comb. There is a practical application for that I will discuss in jet transform. From these few examples we solved, the conclusion is whenever you want to know the nature of the filter, continuous case, omega tends to 0, omega tends to infinity, lowest and highest. But a discrete case, omega tends to 0, omega tends to pi. Of course, we have 3 dB cutoff. How to say same answer in Laplace domain? S tends to 0, S tends to infinity. But Z domain, Z tends to 1, Z tends to -1, because recollect Z equals to e power j omega, our conversion formula. Z equals to e power. Low pass filter means starting more, ending less. 3 dB cutoff ideal case is 1 by root 2. High pass system means starting 0, ending 1, 1 by root 2. Band pass, what we checked in the problem just now, starting, ending. Band stop filter means, so whenever you want to know the nature of the filter, this table is sufficient. This table I prepared for ideal case. For an ideal filter, I am giving this table. Practical filter, 1 need not be 1, sir. This can be 2 or 3, 0 need not be 0. It may be 0.5 like this, because for a practical filter, the stop band response tending towards 0. Roughly, I am sketching the curve. If you take a practical low pass filter, it is tending towards 0, not exactly, but in ideal, blindly we are taking 0 or not. Okay? This table is prepared for ideal characteristics. Low pass filter means starting more, ending less. High pass system means starting 0, ending more. Band pass means starting, ending 0. Band stop means starting, ending. Actually, the advantage of giving this table for you, suno pehle, idhar dekho. Suppose this n-log transfer function is given, sir, and asked for what is the nature of the filter. Normal build-up is what? S plus j omega, trial and error, time waste. What is limit s tends to 0, h of s? If I am substituting s plus 0, 0 by 3 is. Similarly, what is limit s tends to infinity, h of s? If I am substituting s plus infinity, take s square common in the denominator. 1 by s, 1 by infinity, 0. Starting 0, ending 0, 100% which filter? Starting and ending 0 means 100% which filter, sir? Band pass filter. No need to waste our time. No need to waste our time. This table I have given for ideal filter. Practical filter, they may differ. Practical filter, they may differ. Okay? Analog case, omega tends to 0, omega tends to infinity, but discrete. Discrete case, omega tends to 0, omega tends to pi. There you must be careful. For a digital filter, if you substitute omega tends to infinity, problem gone. Discrete case, lowest frequency 0, highest frequency is pi. Okay? Let me give some practical example also for you, because I prepared the table for ideal, sir. Suppose I have given impulse response samples like this. No arrow mark is mentioned means it is covering 4 samples, 0, 1, 2, 3 or not. Everyone tell me it is acting like which filter? H of n is 5 minus 4, 3 minus 2. Come on, respond. This impulse response is acting like which filter? We have to check the DC response and high frequency response. DC gain omega 0. DC gain means omega 0. High frequency means omega plus pi. Correct or not? DC gain means h of e power j0, which is simply addition of the samples from our definition. Yesterday's first question we solved like this only. High frequency gain. I mentioned just now with you, check the values at starting and ending. 0 to 3 hn into minus 1 whole power n. Omega plus pi means scaling factor. 5 minus 4 plus 3 minus 2 is 2. For odd samples, negative sign becomes positive. 5 plus 4 plus 3 plus 2, 14. Starting to ending 14 means which filter? Starting to ending 14 means high pass system. High pass. Roughly the graph is something like this. Starting to ending 14, a practical system. So it is not like 1 0 or 0 1 sir. Practical system can have different gain also. Come on friends. Answer me for this impulse response. Nature of the filter. Minus 0.8 whole power n un. A power n un style I have given minus 0.8 whole power n un. Come on, come on. A power n un spectrum, every one of you know, 1 by 1 minus a e power minus j omega. A power n un means 1 by 1 minus a e power minus j omega. With that logic, you tell me. It is acting like which filter? A power n un 1 by 1 minus a e power minus j omega. Based on that logic, it is acting like which filter? Good. Most of you have given correct answer. What is the frequency response of this one, sir? According to our formula, 1 by 1 minus a e power minus j omega. If I am taking omega plus 0, sir, 1 by 1 minus, already it is minus 0.8, so plus 0.8. 1 by 1.8, approximately you feel denominator like 2, 1 by 2 is 0.5 approximately. You feel like 2. What happens if I substitute omega plus pi? 1 by 1 minus 0.8. That is 1 by 0.2 is 5 or not? Starting 0.5, ending 5 means high pass system. Starting 0.5, ending 5. High pass filter or not? So don't forget and don't scold me in the exam, all bachas. This table is for ideal characteristics. Practical filter, the answers may differ. 1 may be any number, 0 need not be 0. Very good. Okay, those who have completed that, please answer me this question. a filter described by the difference equation like this: y of n equals to 0.5 yn minus 1 plus 0.5 xn. Find the half power point frequency. Means 3 dB cutoff we want. What is half power point frequency meaning? At that frequency, magnitude becomes 1 by root 2 of the value at origin. 1 by root 2 of the value at difference equation is given, asked for half power point frequency, indirectly 3 dB cutoff. 3 dB cutoff frequency is asked, sir. For the first order difference equation, find the half power point frequency. Find the half power point. Solve for frequency response and equate like this. Then you know the answer. Solve for frequency response. We want omega c answer. We want omega c. Take a pen and paper and solve the problem. First, everyone solve for h e power j omega answer, which is y e power j omega by x e power j omega. Take the DTFA, frequency response we want. Solve for omega c number. I want omega c. Tell the answer. I am not asking you the nature of the filter. I want omega c, 3 dB cutoff frequency I want. I hope you have started the problem. Think. I will discuss, think. Anyone? What is omega c number? Array 1 by root 2 is its magnitude level. I am asking omega c number. One girl has given the answer. Good. 0.72. Correct, ma? Very good. Another fellow. Sujat. Very good. Anyway, if you take omega 0, 0.5 by 0.5, that is 1. Here I am taking magnitude whole square, mod h e power j omega c whole square, such that right side it becomes 1 by root 2 whole square. H e power j0. Magnitude whole square meaning is what, sir? H into H conjugation. H into 0.5 divided by 1 minus 0.5 e power minus j omega. Conjugation of that one means 0.5 by 1 minus 0.5 e power. Solve for magnitude whole square, which is H into H conjugation. This is H. Conjugation means exponential negative becomes positive. Numerator 0.25. Denominator, actually omega place we should substitute omega c. 1.25 minus cos omega c. Everyone see the simplifications are. Numerator 0.5 into 0.5 means 0.25. Denominator 1 into 1 plus 0.5 into 0.5. 1.25. 0.5 common multiplier becomes cos omega c. Okay. From this you can say 1.25 minus cos omega c equals to 0.5. Cos omega c is 0.75. Omega c becomes cos inverse of 0.75. Cos inverse of 0.235 radian, or further simplification enjoyment 0.72. Radian means radian per second. I'm a lazy fellow. Radian per. Don't expand exponential and waste your time. Whenever exponential is there, to convert complex term to real term with less number of steps, everyone see the cursor, sir. The easy technique is go for magnitude whole square. Magnitude whole square is H into H conjugation. Only in 2 steps it is modified to real term. If you expand e power minus j theta as cos theta minus j sin theta, 5 to 6 steps are needed for getting its magnitude, time waste. To convert complex term to real term with less number of steps, what is the technique? Whenever magnitude is given, go for magnitude whole square. H into H conjugation. Simplification is very easy. Simplification is very easy. Very good, very good. Most of you answered. Very good. .72 here. DC response 1. Don't feel always DC response is 1. Never directly equal to 1 by root 2 directly. For a given problem, DC response may be number 5 or number 8. Suppose H of e power j0 is 8, sir. 8 by root is correct. If you take 1 by root 2, gone. So the correct way of saying that is 1 by root 2 of the value at origin. 1 by root 2 of the value at half power point frequency indirectly means 3 dB cutoff. Half power point frequency indirectly means 3 dB cutoff. Think about this question, sir. All pass filter question. Consider the system described by a first order difference equation where A and B are real. What is the relation between A and B? What is the relation between A and B such that magnitude is 1 for all frequencies? Means it is acting like all pass filter. Mr. Murli Vikas, you check. I don't know how you are getting pi by 3. That is wrong answer. You check somewhere you have done mistake. See your emotional steps carefully. Maybe somewhere you have done mistake. First order difference equation is given. He wants what is the relation between A and B such that magnitude is 1 for all frequencies. Means it is acting like a all pass filter, sir. Magnitude is everywhere 1 means it is acting like all pass filter. Come on, make a try. Again solve for frequency response and you tell me what is A in terms of B. What is A value in terms of B? What is A value in terms of B, sir? If I take Fourier transform of this expression, y equals to a e power minus j omega y plus bx, they are all function of frequency. I am not writing that. They are all capital X, Y, they are all function of. So from which frequency response is Fourier transform of output by inputs are b plus e power minus j omega divided by it is stated in the question magnitude is 1 for all frequencies. If magnitude is 1, magnitude whole square also, which we can write as h into h conjugation. So b plus e power minus j omega by 1 minus a e power minus j omega. What is conjugation, sir? B plus e power j omega by 1 minus a e power j omega. That is conjugation. First you take frequency response b plus e power minus j omega by 1 minus. Conjugation is like this. If I simplify, numerator becomes b square plus 2b cos omega plus 1. B into b square. E power minus j theta into e power j theta 1, sir. With the b common multiplier it is. Similarly, denominator is 1 minus 2a cos omega plus a square. If numerator and denominator are equal, then only the cancellation occurs to produce answer as 1. So compulsory what is b in terms of a? Minus a. If you take b equals to minus a, then only it is wait. Excellent. Very good. Wait for some time. In Z domain, there is a direct condition for all pass filters. Whenever poles and zeros are reciprocal to each other, it is an all pass filter. No need of all this mathematical build-up. In Z domain, we are learning that whenever poles and zeros are reciprocal to each other, it corresponds to all pass. No need of this maths. Okay. Whenever poles and zeros are reciprocal to each other, it is going to act like a all pass filter. Whenever poles and zeros are reciprocal to each other. Based on that point, every one of you can tell the answer. This answer, I am repeating filters again there also. Of course, next 2-3 days, our emotion is filters only. Okay? I am making a habit for you to convert complex quantity to real quantity. What is the simple technique? Go for magnitude whole square. Previous problem also we have done it or not, sir? Once you take magnitude whole square, complex term is easily converted to real term without doing stupid expansion. Answer this model. Input is 1 plus 4 cos n pi. Output we want to get as 4 for the given system expression. What is alpha and beta that will retain the respective output answer? By trial and error, you have to answer this question from the given options. Input we selected as 1 plus 4 cos n pi. to get output as 4, what must be alpha and beta? So what is the frequency response I can take for this expression, sir? Y e power j omega by x e power j omega. What is the frequency response answer? 1 plus alpha e power minus j omega plus beta e power minus j2 omega. Solve for its Fourier transform. Everyone listen here. What are the input frequencies you have? 0 and pi. Input frequencies are 0 and pi. Output number is a constant number. It means it is due to only DC component by suppressing second frequency, or it may be due to both the terms. That point only we have to check now. The output may be due to both the frequencies or only due to DC component. Maybe that point only we are checking now. Listen. By trial and error. By trial and error, what is the first option given, sir? Alpha to beta 1. By trial and error. If I take alpha to beta 1, what will happen to frequency response expression? Tell me everyone. 1 plus 2 e power minus j omega plus e power minus j2 omega. Alpha place 2, beta place 1. That is nothing but 1 plus e power minus j omega whole square. Alpha to beta 1 means 1 plus e power minus j omega. So this system response, now we have to check for which frequencies. What are the input frequencies for us, sir? 0 and if I substitute omega place 0, 1 plus 1 whole square is 4. If I substitute omega place pi, 1 minus 1 whole square is 0. So 1 number multiplied by 4, but cos n pi multiplied by 0 means we got the required output. So 100% what is the correct answer for this question? Alpha to 1. Alpha to, by taking alpha to beta 1, it becomes 1 plus e power minus j omega whole square or not? By taking alpha to, because as I know the answer, for my convenience, I have chosen that as first option. But if it fails, you should go for second option, trial and error. Simple logic is input frequencies are omega, 0 and pi, sir. Output has a constant number, means DC component only. Maybe it is due to first frequency or maybe due to both frequencies. That point only we are checking. But luckily it is due to first component only. Because if you substitute omega place 0 with this alpha beta, that scaling factor is 4. 1 into 4 is 4. Second frequency suppressed, cos n pi into 0 suppressed. So alpha to beta 1. This problem you can solve by trial and error. This problem you can solve by trial and error only, not directly. By trial and error, we can feel alpha equals to 2, beta equals to 1 is the correct answer by trial and error. If it fails, go for second option like that. Okay. One fellow is saying in the all pass filter, he missed the minus sign. Life gone. Gaya, 2020 became 2021 now. Be careful, sir. Signals is like music. When you listen the tones properly, it will come to you. If you are not listening, it becomes nice for you. Enjoy the music properly. By substituting omega place 0, system response has given scaling factor of 4, sir. But by substituting second frequency, gone. System response become 0. Okay, I'm moving to the next model. Once DRDO used to conduct a separate paper, they have asked this model, very old. Of course, nowadays everything is through gate score only. Think and answer me, study the question. Study the question, sir. Input signal with length 3 is applied to an LTI system having impulse response of length 5. So input has 3 samples, system has 5 samples. Mod Hn less than or equals to L, mod Xn less than or equals to B for all n. Maximum amplitude of input and system given. Then he wants maximum value of Y0, means output spectrum at 0. Output spectrum at 0 he wants. Maximum value of. So out of the 4 options, what is correct, sir? Out of the 4 options. Input length is given as 3 samples. Impulse response length is given as. Another point is mod Xn less than or equals to B, mod Hn less than or equals to L. Maximum amplitude of input and system is also given. He wants Y0 maximum. Output spectrum is input spectrum multiplied by system response. Instead of y e power j omega, that fellow has represented as y omega. Don't bother. We know signals are discrete only. Don't be tensed. Instead of y e power j omega, he followed this notation. Y0 means x0 into h0. Y0 means x0 into spectrum at 0 means area under the signal sigma xn. H0 means sigma hn. Spectrum at 0 means time domain, area under the signal or not, sir? Maximum value indicates modulus. Maximum value indicates take modulus. Input length is mentioned as how many samples, sir? 3 samples. I am varying summation from 0 to 2. It is not a rule you can take from -1 to 1 also, because it is not mentioned causal or non-causal. I am assuming it because it covers 3 samples 0 to 2. System length is 0 to 4. What is mod Xn maximum amplitude? B. What is mod Hn maximum amplitude? First time B added how many times? In the first summation B added 3 times. Second summation L added. What is the new answer? 15 LB. Take spectrum at 0. It is area under the signal. Capital X0 is sigma Hn. Capital H0 is sigma Hn. Input length 3 means vary summation from 0 to 2. I am assuming, I feel like causal, you can take from -1 to 1 also. Nothing will happen. H0 sigma 0 to 4, sir. Mod Xn B, highest amplitude, peak amplitude. Mod Hn L, 15 LB is the answer. 15. Application of convolution property as well as spectrum at 0 means area under the signal. Area under the signal. Spectrum at 0 means area under the signal. Logic, sir. Okay, just a minute. Yes. Spectrum at 0 means area under the signal. That result is 15 lb. 15. Think about this model, sir. An LTA filter is described by this difference equation. Obtain the magnitude and phase response. An LTA filter is described by this difference equation. We want magnitude and phase response means first we have to calculate He power j omega. In slide number 12, same question we solved. Alpha to beta 1. Just I am showing it. Observe here. Slide number 12. Alpha to beta 1. With alpha to beta 1, it is looking like 14th slide expression or not, sir? See here, everyone. Alpha to beta. So from page 12. 12th page already we solved. Why? Again, repeated overaction. We know frequency response expression with alpha to beta 1 only. Alpha to beta. What is the frequency response expression, sir? 1 plus e power minus j omega whole square. From page 12, we got frequency response as 1 plus e power minus j omega. But that fellow wants now magnitude and phase response separately. Separate the terms. Internally, if I take half frequency common. Internally, if I take half frequency common, what is the adjustment we need, sir? To get 1 e power j omega by 2, still you are left with another half frequency e power minus. To make that as cos function, what adjustment is needed? To make that as cos function by 2. So this answer becomes 4 cos square omega by 2 e power minus j omega. 4 cos square omega by 2. So what is the magnitude response answer, sir? Mod h e power j omega equals to modulus of 4 cos square omega by 2. And phase response also he wants separately. Theta of omega equals to minus omega. In e power j theta, what is the phase angle? Minus. Everyone see the 12th slide. Alpha to beta 1. That is what the expression given now. We already know frequency response. First bit is obtain the magnitude and phase response. We got the answer like this. We got the how you can apply m plus n minus 1 rule. He has asked for sample value or maximum amplitude, sir. He has not asked what is the length of the output. What is spectrum at 0? How you can apply m plus n minus 1? First obtain the magnitude response and phase response. Obtain the magnitude response and phase response. In e power j theta, phase angle is minus omega. Magnitude of this quantity 4 cos square omega by. Second bit, of course, everyone will answer. Find the output when you apply input as this term. What are the two input frequencies for us? Omega 0, omega pi by 2. Omega 0, omega. Due to that, what is the output, sir? Due to that, what is the output? Omega 0 means 4 cos 0 becomes 4. DC response cos 0 is 1, 10 into 4. 4 into omega pi by 2 means what is 4 cos square pi by 4 answer, sir? Substitute omega place pi by 2. 4 cos square pi by 4. 4 cos square cos of pi n by 2 plus pi by 4. Extra phase angle to be added is minus pi by 2. Minus omega. What is omega number? Minus omega means minus. So this 2 is nothing but mod h e power j pi by 2. This is nothing but theta of pi by 2. Introducing magnitude and phase response. Introducing magnitude and phase response. DC response omega plus 0 means it becomes simply 4 for us. DC response omega plus 0 means simply it becomes 4, sir. This problem I have not solved for getting output. What is the phase response answer we got here? Everyone see? What is the phase response answer we got? Minus omega. Without solving this problem also you can say phase angle is minus omega. Without solving also you can say phase angle is minus omega. Everyone see here. Listen very carefully this point. How I can find out the impulse response of this expression, sir? Input impulse, output is called as impulse response. Xn is del n, then y of n is hn called as impulse. So what is the impulse response of this system expression? Hn equals to xn place substitute del n, yn becomes hn. Del n plus 2 into del of n minus 1 plus del of n minus 2. If I draw the impulse response, how many samples it contain? 3 samples it contain. Means it is a FIR filter. FIR filters can satisfy linear phase response. FIR filters can satisfy linear phase response. What is their general form is minus alpha omega if it is symmetric, means even function, minus alpha omega plus beta if it is anti-symmetric. Minus alpha omega if it is symmetric, minus alpha omega plus beta if it is symmetric means even, anti-symmetric means odd. How to find out alpha means with respect to the sample value it is symmetric, that is alpha. In this example h of n is symmetric with respect to which value? N equals to 1. H of n is symmetric. H of n is symmetric with respect to n equals to 1. So alpha is 1. Automatically what is the phase angle? Minus alpha omega means alpha is 1 means minus omega is the result. Everyone see carefully. This is a FIR filter, finite impulse response, because it contains only 3 samples. FIR filter can satisfy linear phase response only when impulse response is symmetric or anti-symmetric. Symmetric form phase angle minus alpha omega, anti-symmetric means odd function will have extra 90 degrees. Beta is the 90 generally. How to decide alpha? With respect to the sample it is symmetric, that is alpha. In this example it is symmetric with respect to which value? N equals to 1, alpha is 1. That is a direct way of saying the answer. After solving also we got same or not. Anti-symmetric also let me show you. Minus alpha omega plus beta form, where we solved this high pass filter question. Yeah, 7th slide. Everyone just see here. What is the impulse response? I can write here del n minus del of n minus 1, xn del n yn hn. It means we have samples at 0 and 1 set. Now it is looking like odd function or even function. It is looking like odd function with respect to non-integer value, no problem. Phase spectrum is continuous in our case. So what is the phase angle answer? You can write here minus 0.5 omega, alpha is minus 0.5 because it is odd. Blindly what phase angle to be added? 90 degrees. After sketching h of n, it is looking like anti-symmetric with respect to non-integer sample, no problem. Our phase spectrum is continuous, sir. We are bothering about phase here. With respect to 0.5, you feel it is odd function. So alpha is 0.5 plus pi by 2. What answer we got after solving there? Same thing or not? Minus omega by 2 plus. So be careful. FIR filters can satisfy linear phase only when the impulse response is symmetric or anti-symmetric. In this example, h of n is symmetric with respect to n equals to 1, alpha equals to 1, minus omega answer. But in high pass filter case, it is anti-symmetric with respect to 0.5, means alpha 0.5 plus pi by 2. Why pi by 2? Odd function means blindly plus or minus 90 degrees. That is what we studied. So that is what I have written in this slide. Don't have a wrong thought. Every FIR filter has linear phase. That is wrong thought. Every FIR filter cannot have linear phase. FIR filters are satisfying linear phase means what is compulsory requirement? What is compulsory requirement? Impulse response must be symmetric or anti-symmetric. Idhar dekho. I mentioned symmetric means minus alpha omega. How to decide alpha? With respect to the n value that is symmetric, with respect to n equals to 1, we can feel it is even symmetric or not. With respect to n equal, that is what I have written neatly here. H of n is symmetric with respect to n equals to 1, alpha 1. Suppose it is symmetric with respect to origin, sir. Phase is 0. Suppose if it is symmetric with respect to origin. Just cross check once again the 7th slide. For this difference equation, I have written impulse response. Xn del n yn becomes hn. Input impulse, output impulse response. It is anti-symmetric with respect to non-integer sample alpha 0.5. Why extra pi by 2? Odd function will have extra 90 degrees. After doing mathematical simplification also we said that. Correct or not? We are not saying every FIR filter will have linear phase, sir. FIR filter is satisfying linear phase means compulsory impulse response must be symmetric or anti-symmetric. Compulsory impulse response must be symmetric or anti-symmetric. Symmetric form minus alpha omega, anti-symmetric mx plus c style. Phase angle is 90 degrees for odd function or not? Phase angle is 90 degrees. Don't make a note that every FIR filter has linear phase. That is a wrong word. Every FIR filter cannot have linear phase. FIR filter has linear phase means FIR filters are obeying linear phase means what is our compulsory requirement? They must be symmetric or anti-symmetric. Don't get tension for the word symmetric, anti-symmetric, sir. Even odd. Symmetric means even. Anti-symmetric means odd. Every FIR filter cannot have linear phase. Every FIR filter cannot have linear phase. For odd function, what is the phase angle extra added? 90 degrees. That is the reason beta pi by 2. Any odd signal means it will have extra pi by 2 or not? With this hint, try to answer the next two models which I am showing to you. After calculating impulse response, if the considered system is FIR filter, there is a chance of, if the considered system is FIR filter, there is a chance of linear phase. That point you have to check on your own. Okay, I am going to next slide. Why odd will have minus pi by 2? अरे सो रहे क्या? Real and even function phase is 0 or 180. Odd function plus or minus 90 degrees. कितना बार बोला क्लास में 4/8 सीरीज से? सो रहे क्या? Even function fixed phase angle 0 or 180. Odd signal plus or minus 90 degrees. How many times I told this point? In the 7th slide, what we observed, impulse response is antisymmetric means hard. Because of this J multiplier only, we have added 90 degrees. Na? Again, that fellow is asking the question. All these days he is sleeping. From 4/8 series onwards, we are discussing that point. Odd function will have phase angle of 90 degrees. Okay. Please try this model, sir. Draw the impulse response, you will know. Draw the impulse response graph. How neatly the question is given. See, the impulse response of a causal linear phase discrete system. He has used the word linear phase means what is compulsory for you? Symmetry or anti-symmetry compulsory. Linear phase word is used. At 0, what is the amplitude level given? 2. At 1, what is the amplitude given, sir? -3. 2 it is 0. 3 it is 3. 4 it is unknown. In this example, impulse response is symmetric or anti-symmetric? In this example, impulse response is symmetric or anti-symmetric? It is looking like anti-symmetric with respect to n equals to 2 or not. It is anti-symmetric with respect to, as 1 and 3 samples are opposite, 0 and 4 must be opposite or not, sir? Opposite amplitudes. 1, 3 samples opposite means 0 and 4 samples also. H of n is anti-symmetric with respect to n equals to 2. So what is the phase angle form? What I mentioned in the previous slide. Antisymmetric means minus alpha omega plus beta. What is alpha? Circled sample. Alpha is 2. Beta, of course, fixed. First it is asked for K. K number -2. K number -2. 1, 3 samples opposite means 0 and 4th sample opposite. H0 must be minus H4. As H1 is minus H3 sample, anti-symmetric. So what is the slope of the phase curve? Mx plus C form. Mx plus C form. What is the slope you got? -2. K -2, slope -2. K -2, slope -2. Good. Anti-symmetric, very good. Slope means, slope is decided by alpha only, bacha. Mx plus C forms are odd function means 90 degrees. You do one thing. Still, if you are unable to recognize pi/2, every one of frequency response emotional definition, use this definition and solve for phase response. 100% you will get that answer only. 100% you are going to retain this answer. -2 omega plus pi/2. देखो एक बार try करो using definition. See how beautifully the question is framed, sir. Causal linear phase. The word linear phase is used means compulsory requirement is what? Symmetrical or anti-symmetrical impulse response. That is what we mentioned in the previous slide or not? In this example, it is anti-symmetric with respect to n equals to alpha 2. Why I added pi by 2? Because it is odd function. Anti-symmetric. On linear phase, I have given 2 more models. Let me see how many of you will give correct answer. Frequency response, maybe it is very light for you, is e power minus j omega by 4, sir. Cos 5 pi n by 2 is the input. He wants the output. Input is cos 5 pi by 2 n. System is e power minus j omega by 4. Get the output. Input sinusoidal means we know output also sinusoidal. Think that way. Tell me the answer. How we are taking alpha? Arey bacha. With respect to the sample, it is symmetric or anti-symmetric. That is alpha. Abhi bola na. In this problem, it is symmetric with respect to n equals to 1, so alpha 1. But in the next example, sir, it is anti-symmetric with respect to n equals to 2, alpha 2. Whatever the sample, it is symmetric or anti-symmetric, that is alpha. What I have done here wantedly is, if you observe the input frequency, I have given 5 pi by 2, which is more than pi. Remove the internal periodicity. Discrete signal spectrum periodically repeats for every 2 pi or not. Wantedly, I have given 5 pi by 2. So cos 5 pi by 2 indirectly stands for cos pi n by 2 only. Cos 5 pi by 2 indirectly stands for cos. So what is the output answer, sir? Magnitude is 1 only. But what is the phase angle to be added? Minus omega by 4. What is omega number here? Let me write that also. Otherwise, you will ask me that question also. Cos omega not n form. What is omega? Pi by 2 by 4. Magnitude response of this system is 1. Phase angle is minus omega by 4 means pi by 2 by 4. Pi by 2 by cos pi n by 2 minus pi by 8. For making confusion, wantedly I have given frequency as 5 pi by 2. 5 pi by 2 means more than pi. Remove the internal periodicity. 2 pi plus pi by 2. We know discrete signal spectrum repeats for every 2 pi or not. Discrete signal spectrum repeats for every 2 pi. At least make me happy for the right side example, everyone. Very funny question. The last model on linear phase in this chapter. Still emotion is there. Filter design. Come on, friends. Signal data is given. We want the phase spectrum value at 0.25 pi, means pi by 4. Draw the graph. Everyone can recognize what is the phase angle. Come on, come on. If you draw this graph, at minus 1, 1, 3, 5. All these sample amplitudes are how much? 1. Whereas at 0 and 4, amplitude how much? This signal xn is looking like symmetric or anti-symmetric. Symmetric with respect to which sample? N equals to 2. 1, 3 samples, 0, 4 samples are same. What is the phase angle you can write? Minus 2 omega. Minus 2 omega because alpha is 2, sir. It is symmetric with respect to 2. Anyway, he wants the phase angle at which frequency? 0.25 pi means pi by 4. Substitute omega place pi by 4. Substitute omega place pi by 4. We got the result or not? As it is symmetric with respect to n equals to 2, direct phase angle minus 2 omega. Minus 2 into that frequency, given frequency. Minus pi by. So in these problems we solved. What is the point of observation, sir, everyone? FIR filter has linear phase means what is the immediate thought your chip requires? FIR filter has linear phase means what is the immediate thought your chip requires? It should obey either symmetry or anti-symmetry condition. It should obey either symmetry or anti-symmetry condition. You cannot say every FIR filter has linear phase. You cannot say every FIR filter has linear phase. Take a short break and come back. 20 minutes. Take a short break and come back. Dekho Sudeep, you want this page? Okay, let us start our discussion. Last 3-4 examples we checked about linear phase. FIR filters are having linear phase only when the impulse response is symmetric or antisymmetric. Everyone see here. In one of the problem we observed h of n impulse response is symmetric with respect to n equals to 1. Symmetric form is minus alpha omega. How we have decided alpha? With respect to the value it is symmetric, that becomes alpha. Alpha 1. Theta of omega is minus omega. In the next slide we observed it is anti-symmetric with respect to which values are? N equals to 2 means alpha 2. Alpha omega, alpha is 2 minus alpha omega plus beta. Odd function means blindly pi by 2 addition. In the last example, x of n is symmetric with respect to n equals to 2. So minus alpha omega form. Anyway, the phase angle is asked at pi by 4. We substituted. So when you can say FIR filters can satisfy linear phase response means only when impulse response is symmetric or anti-symmetric. Only when impulse response is symmetric or anti-symmetric. Okay. Let us discuss the next concept. We want energy in the signal, that is SAP function sin omega Cn by pi n. Finding energy means in frequency domain it is linked to which property? Finding energy means in the frequency domain it is linked to which property, sir? Parseval's relation. Parseval's relation or not? Tell me. Parseval's relation. In Fourier series, I am making a comparison again. In Fourier series, we studied this property as what? 1 by t integral 0 to t mod xt square dt equals to sigma minus infinity to infinity mod Cn square. That is what we have taken in Fourier series, sir. In Fourier transform, CTFT. In Fourier transform, how we consider integral mod xt square dt equals to 1 over 2 pi integral of mod x omega whole square. How this property is going to change in this chapter, sir? Discrete time Fourier transform. Instead of integration, energy in the discrete signal means sigma mod xn whole square. Sigma mod xn 1 over 2 pi integral minus pi to pi mod xe power j omega whole square d omega. Like continuous Fourier series, last chapter we are learning discrete Fourier series where the formula modifies to 1 by n sigma mod xn square power of a periodic signal for one period 1 by n sigma mod xn square equals to sigma k equals to 0 to n minus 1 mod ck square. Ck is the discrete Fourier series coefficient. So to answer this question, we should apply this property, sir. You already know Parseval's theorem is called as law of conservation of energy. Either in time domain or frequency domain, complete energy is preserved. Either in time domain or frequency domain. Parseval's theorem is possible in Laplace and jet transform also, but no practical significance, sir. That is the reason we are not learning. They don't have any practical significance. Carry on, use the property and check what is the energy in the SAP function. Every one of you know its spectrum is what? Rectangle from minus omega c to omega c. Calculate the spectrum and find out the energy. Take its spectrum and find out the energy. When you take Fourier transform of this one, it is a rectangle that covers from minus omega c to omega c. So according to Parseval's theorem of DTFT, sir, 1 over 2 pi integral minus omega c to omega c spectrum amplitude whole square d omega, answer becomes omega c by continuous case. Also we studied similar style, sin 80 by pi t, sin 80 by pi t form. Now discrete, sin omega cn by pi n. There we studied a by pi. How omega c can be greater than pi, bacha? Here we have a band limited spectrum that is periodically repeating. If it is greater than pi, drag to that range, less than pi range. Remove the internal periodicity. Remove the internal periodicity of 2 pi, sir. One of our friend has asked me this question only in the afternoon session. Energy means what is the immediate thought you need. If you fail in time domain, you should go in frequency domain. Frequency domain, how to solve that? By using the Parseval's relation. Using Parseval's theorem, we are solving it, sir. Okay. Okay, let us discuss the next model. Now we want area under product of two SAP functions. Sigma SAP function multiplied by SAP function. Area under product of same signals we studied as Parseval's. Area under product of two different signals we studied as which theorem? Plancherol's. Area under product of two different signals we studied as Plancherol's theorem or not? Sigma xn yn equals to 1 over 2 pi integral minus pi to pi x e power j omega y e power j omega d omega, sir. Luckily both are real signal. If one of the signal is complex, we need conjugation. Plancherol's theorem. Enjoy. Take Fourier transform of individual SAP functions and check the results, sir. Sin omega cn by pi n is our standard form like previous slide. Sin omega cn by pi n, sir. What is the Fourier transform we can take for the first signal? Sin n pi by 4 by 2 pi n means a rectangle that covers from minus pi by 4 to pi by 4 with amplitude of 1 by 2. What is the Fourier transform of second one? Another rectangle that covers from minus pi by 3 to pi by 3 with amplitude of 1 by extra 1 by 2, 1 by 5 are there. So when you multiply both rectangles, they are limited for which range? When you are multiplying them, both the spectrums are pi by 4 is the limited range. Multiply the amplitudes of the spectrum 1 by 2 into 1 by 5. X e power j omega into y e power j omega. Do that simplification. Good. Most of you answered. Good. In one of the exam, the question is framed like this. X of n is del of n plus 2 minus 2 del n plus del of n minus 3. The value of 1 by pi integral minus pi to pi x e power j omega cos square omega d omega is asked. X of n data is given, sir, with its Fourier transform as x e power j omega. Then he wants this value. Again, area under product of two different spectrums means Plancherol's relation or not. You can feel this like y e power j omega. You can feel this like y e power. There is no need of multiplying the spectrums. Cos square theta you expand 1 plus cos 2 theta by 2. Cos square theta you expand 1 plus cos 2 theta by 2. Find out inverse Fourier, you are getting impulse form. This answer equals to what in time domain? Sigma xn into yn. Already xn signal is known. Y of n signal you should calculate. Cos square theta expansion calculate. Wantedly what that fellow has missed here. 1 by 2 pi tag will be there. Wantedly he missed 2. So the correct answer is what? 2 times sigma xn. Xn you know. Expand cos square theta which is 1 plus cos 2 theta by 2. Further 1 by 2, 1 by 4 e power j2 omega, 1 by 4 e power. Write the inverse Fourier. Then you multiply xn and yn with 2 multiplier. You will know the result. Okay. Simple problem. HW. Area under product of same spectrum is Parseval's. Product of two different spectrums is what? Plancherol's. Wantedly missed the 2 multiplier. 1 by 2 pi formula. 1 by 2 pi is there in formula, sir. But he wants 1 by pi wantedly means 2. We should cross multiply here. Let us go to next one. For the signal shown in figure, find the given quantities without calculating DTFT. Find the given quantities without calculating. Of course, in the exam, that statement is not given for you without calculating. Somehow you should get the answer. If that statement is given, indirect hint is given for us. You can make a number of stars for this problem. For all competitive exam fellows, DTFT favorite model is this. Favorite model. Okay. Without calculating the DTFT, we should find out all the given quantities. Everyone tell me. Spectrum at 0. Spectrum at 0 means what will happen in the time domain, sir? Area under the signal. Signal varies from -3 to 7. Spectrum at 0 means area under the signal. Just add all the amplitudes. Add all the amplitude levels of impulses. At origin also it is there, sir. At origin it is having amplitude of 2. At 0 also impulse is there. Just add all the amplitude levels. Spectrum at 0 means area under the signal. Spectrum at 0 means area under the signal. Add all the impulses. Answer is 6. Second bit, we want spectrum at pi. We observed from the definition. Omega place pi means scaling factor is -1, sir. For even samples, it is multiplied by 1. Odd samples -1. Simplify. I think answer is 2. You do that simplification. For even samples, it is multiplied by 1, sir. Odd samples multiplied by -1. Odd index, it is multiplied by -1. Answer 2. C and D bits are linked to inverse Fourier definition. Everyone recollect? 1 over 2 pi integral minus pi to pi x e power j omega e power j omega and d omega is inverse Fourier definition. In the third bit, area under the spectrum is asked means take signal at origin or not, sir? Make this exponential one. How to make exponential as 1, sir? Small x0, signal at 0 is 2. Observe the signal graph, signal amplitude at 0 is 2, 4 pi. Debate. That fellow want x e power j omega e power j2 omega d omega. Again in comparison with inverse Fourier definition, n place 2 or not, sir? E power j2 omega means n place 2, 2 pi into signal at 2. What is signal at 2 answer? 0. Signal at 2 here. It is 0, sir. 2 pi into signal at 2. Next bit, area under spectrum square is asked. Spectrum whole square area means automatically Parseval's theorem or not? 2 pi into sigma mod xn whole square. 2 pi into sigma mod xn. Find out the energy in the signal. Sum of square of each sample. Find out the energy in the signal, sir. Sum of square of each sample. Energy in the signal is 14. Bacha, what is there? -1 whole square plus 1 whole square plus 2 whole square, like that. Energy in the given signal is 14, sir. Next bit is combination of frequency differentiation and Parseval's theorem. Again, it is looking like area under spectrum whole square only, but a differentiated spectrum is given for us. So it is combination of frequency differentiation and Parseval's theorem. 2 pi into sigma -3 to 7 d by d omega x e power j omega means what you will write? Minus j n xn whole square. Minus jn. So 2 pi into modulus of n into xn whole square, sir. Every sample amplitude multiplied by time index. -1 into x minus 1, -2 into x minus 2, like that. Every sample amplitude multiplied by time index. Frequency differentiation and Parseval's theorem, both you should apply. Frequency differentiation and Parseval's theorem. Do that enjoyment. This number you will get. n into xn whole square means every sample amplitude multiplied by time index. Every sample amplitude multiplied by time index, sir. Last one, angle. First of all, it is looking like a FIR system. It is symmetric with respect to which sample, sir? Xn is symmetric with respect to n equals to 2. So directly, what is the phase angle? Theta of omega is, because it is symmetric, minus alpha omega, alpha number 2. It is symmetric with respect to 2 means phase angle becomes what? Minus 2 omega. Correct or not? If it is combination of Parseval's theorem and frequency differentiation, today's starting point is frequency differentiation only. D by d omega means minus jn, sir. As we are taking modulus n into xn whole square. What is the meaning of n into xn? Time index multiplied by amplitude. Minus 3 into minus 1, minus 2 into 0, minus 1 into 1, like that. N into xn. Time index multiplied by amplitude for that whole square. As this signal is symmetric with respect to n equals to 2, directly phase angle is minus 2 omega. For this type of problems, you solve separately phase angle, then you will know the beauty. Why we are using simplified technique. You solve phase angle of that one directly by using our stupid definition. Tomorrow morning, you will decide answer is minus 2 omega, which we are in a position to say directly now. This is a favorite model for all competitive exams, fellow sir. Favorite model. First 2 bits are forward definition. Next 2 bits are inverse. Next 2 bits Parseval's theorem. Phase response, direct logic. Phase response, direct logic. Everyone study this question and tell me correct answer. I think still some of you are in previous question. Take a snapshot, beta. Try for this model. H of n is given as set of 3 samples. H of n is given as set of 3 samples. हाँ तेरे लिए मैं वेट कर रहा हूँ पवार जी, किरण गणपत पवार, तेरे लिए ओनली. अच्छा ये आंसर करो. H of n is set of 1, 2, 2, 3 samples. It is given, sir. F of n is mentioned as convolution result. What you are convolving? H of n with itself. G of n is mentioned as correlation. Everyone recollect how we expressed correlation in terms of convolution, sir? Signal convolved by folded version. I hope you all remember. Signal convolved by folded version. With this given information, tell me what is correct answer. With this given information, What is correct answer is the question. Out of the 4 options, what is correct? Very good. Most of you answered. Very good. There is no need to perform that convolution by our old technique sum by column method, because when you look at the given options, he wants only the nature of the signal. What index h of n covers are? No arrow mark means 0 to 2. According to our thumb rule, what are the limits of f of n? We can say convolution thumb rule is sum of lower and upper limit means 0 to 4. Sum of lower limit 0, upper limits 4 means f of n is causal. F of n is, what about gn, sir? 0 to 2, folded version means minus 2 to 0. Folded version means minus 2 to. So what are the limits of gn now? What are the limits of g of n? Minus 2 to 2, that indicates this is a non-causal. First clarity is f of n causal, g of n non-causal. First clarity. F of n must be causal, g of n must be non-causal. Second clarity, maximum value. We studied autocorrelation function at origin has the maximum amplitude or not, sir? Autocorrelation function at origin. In this example, autocorrelation denoted as Gn. So if I calculate G0, it is energy in the signal. What is energy definition? Sigma signal whole square. Here we have 3 samples only. 1 square plus 2 square plus 2 square. Answer is 9. So what is the correct answer? G of n is non-causal with maximum value of 9. See the beauty of the question. In the question only hint is available. First he wants about the nature of the signal, causality, non-causality. That we can decide by our thumb rule, sir. Sum of lower and upper limits. Maximum value has given the hint that autocorrelation function has maximum value at origin or not, which is energy in the signal. Which is energy in the signal. G of n is non-causal with maximum value of 9. Even if you solve the problem by sum by column method, what you will decide? Same answer you will decide. Time waste. Same answer you are going to decide. G of n is non-causal with maximum value of 9 is the answer, sir. By using your thumb rule, first you obtain the limits, sum of lower and upper limits. After that, you can say the answer. A is not correct. Why, sir? You will not get maximum value as 9. Convolution karo. Do that convolution, then you will know. Maximum value of Fn also has 9. Abbu, who is that fellow? Emotional fellow. Do it properly. Simple multiplication, sum by column method. Yes. Let us see this question. The next 2-3 models which we are solving are coming under that additional topic that is added for EC, only introduction, not complete today. That is discrete processing of continuous signals. That is an additional topic very neatly mentioned this year. Maybe in the last class after completion of DFT or after completion of filters for 1 hour, I am giving that explanation, the topic. But today we are observing only a brief introduction of that one. Study this question, sir. A continuous time signal xt is to be filtered to remove frequency components in a specific range. It is acting like a band stop system. It is stopping frequencies in which range? 5 kHz to maximum frequency is 20 kHz. Find the minimum sampling rate and find the frequency response of ideal digital filter that will remove the desired frequencies from x of t. Everyone see here. Highest frequency is 20 kHz. Such that sampling rate becomes how much, sir? 40. It is acting like a band stop system that is stopping which frequencies? 5 kHz to 10 kHz. We know digital frequency is limited for which range? Digital frequency is limited for -pi to +pi range. So we should drag that analog frequency to this range. Indirectly, we should do normalization. Everyone listen first. Normal expansion of omega is 2 pi f divided by fs. When you perform division by sampling rate, the analog frequencies are dragged into digital domain to which range? -pi to +pi. Omega expansion is 2 pi f. When you perform division by sampling rate, they are dragged into which range, sir? -pi to pi range. This is called as a normalization technique. We are normalizing the digital frequency to which range? -pi to +pi. Listen everyone. From now onwards, to show variation between analog and digital frequency, because next topic is jet transform and filters, I am showing analog frequency with the symbol ohm. Now onwards, omega, digital frequency as small omega. Analog frequency I am showing as ohm symbol, digital frequency as omega. So what is a note? To convert analog to digital frequency, perform division by sampling rate. Is called as normalization, which is called as normalization. So we are normalizing to which range means less than pi range. So in our example, what is happening? 2 pi into 5 divided by 40. Sampling rate is 40 or not, sir? Less than or equals to omega 2 pi into 10 by 40. So that becomes what? Pi by 4 to pi by 2. If original analog system is stopping frequencies from 5K to 10K, with a sampling rate of 40 kHz, the equivalent digital system is stopping pi by 4 to pi by 2 range. Regarding units, numerator radians per second, denominator samples per second. So the new unit is radian per samples. Numerator radians per second, denominator samples per second. So overall new units are radians per sample. In the process of converting analog to digital frequency, we are saying the relation is omega equals to ohm into fs, or you can also say ohm into ts, sampling period. Ohm into ts, 1 by fs is ts or not? So to convert analog to digital frequency, what we have to do, sir? Perform division by sampling rate. The given frequencies perform division by sampling. Everyone see here, 2 pi f units are radians per second, fs units are samples per second. Overall becomes radians per sample. Radians per sample. That is a technique to be followed. Perform division by sampling rate. Perform division by. So if continuous signal is stopping 5K to 10K, what are the values that are stopped by digital systems are? Pi by 4 to pi by 2 when you choose sampling rate as 40 kHz. That approach is called as a normalization. We are normalizing the frequency to which range? -pi to +pi range. -pi to +pi, sir. That range we are doing normalization. अरे Octavia कहाँ है? सो रहे क्या? Highest signal frequency 20 kilohertz means what is sampling rate? 2 times f maximum. I have written ना? Oh, वो भी लिखना है क्या? टू टाइम्स एफ मैक्सिमम. क्या रे, सैम्पलिंग रेट नाइक्विस्ट रेट भी पूछ रहे. To normalize analog to digital frequency, we need this formula. Entire digital filters, IAR and FIR filters, which we are discussing, even the discrete time processing of continuous signals. From now onwards, at least 10 to 15 times I will use this formula. Remember it. Omega equals to 2 pi f perform division by sampling rate. Now onwards, what point you have to remember, sir? Analog frequency symbol ohm I am using. Digital frequency omega for differentiating them. Otherwise, unnecessary confusion will start. Some fellows will say omega dash. I don't want to confuse you. Ohm for analog, omega for digital. Please answer me this model. I hope everyone completed. Please answer me this model, sir. The sequence cos pi n by 4 was obtained by sampling a continuous signal cos ohm naught t with a sampling rate of 1000 Hz. What are the two possible values of ohm naught? Funny fellow. Omega number is given as pi by 4. Sampling rate is 1000 Hz. So what is the relation, sir? Ohm equals to omega into FSR from the previous slide. Ohm equals to omega into. So one frequency is pi by 4 into 1000. 250 pi radians per second. How to get other frequency? Discrete signal spectrum repeats for every 2 pi r naught. Discrete signal spectrum repeats for every. So for the digital frequency that is existing, add 2 pi. For the digital frequency that is there, add 2 pi, sir. So 250 pi, 2250 pi. The two possible values of ohm naught is asked. One is omega into fs direct pi by 4 into 1000. How to get the second frequency means discrete signal spectrum repeats for every 2 pi. So in analog domain, either you take 2250 pi or 250 pi, they corresponds to same digital frequency pi by 4. In analog domain, you take 250 pi or 2250 pi. It corresponds to same. Regarding that schedule, some fellows have confusion. Class is not over, don't get emotion. Tomorrow, Wednesday, Thursday, day after tomorrow also, as usual, 5 to 9 p.m. I am saying about signals class, I don't know. Some sessions are going before me also, I don't know about them. Friday, only I am changing the schedule from 2 to 4:30. Only Friday, sir. Saturday is a festival, I am not taking class holiday. On Sunday, 9 to 1:30. These are signals and system timings. For some fellows, numerical ability, some other subjects are going on. I don't know about them. I am saying about my schedule. Tomorrow, day after tomorrow, 5 to 9, signals as it is. Friday afternoon session, 2 to 4:30 instead of 5 to 9. Saturday, from my side, no session. I don't know about other subjects. Sunday 9 to 1:30. This is the plan. Please cooperate me on Friday, sir. Please cooperate me on Friday. Friday, if from AS, if any other class is there, they will remove. Don't be tense. If any other class is there, they will remove that. They may plan on some other day. Friday, my class will be there 2 to 4:30. After that, syllabus over means everything depends on you. Let me see. I am trying to complete by that day. Let me see. Today I expected I have to start jet transform at 7 o'clock. Still my emotion is going slow only because it is online. What is happening also we don't know. So slowly I am moving. Don't get tension about regarding completion of the syllabus. Till Sunday I planned. I will see. Friday, if any other class is there in that duration, maybe they will postpone to another day. But my slot is fixed on Friday, sir. Okay. Suppose if one more frequency is asked, here two frequencies are asked, sir. If one more frequency is asked, what you have to add? Pi by 4 plus 4 pi. Because discrete signal spectrum repeats for every 2 pi, pi by 4 plus 4 pi you should add. Correct or not? Pi by 4 plus 4 pi. Okay. Think about this model. Think about this model. A continuous time signal xt is to be sampled at the rate of 9 kilohertz. Sampling rate 9k. Impulse response of the digital filter is 0.5 means I am writing 1 by 2 del n plus del of n minus 1. He wants the 3 dB cutoff frequency of analog filter. What is the conversion formula? Just now we checked 2 pi f by fs. First you find out 3 dB cutoff for a digital system, omega c you find out. Then you will know what is fc, sir. Everyone calculate the 3 dB cutoff. We solved already one model on this. How to get 3 dB cutoff? At omega equals to omega c, magnitude equals to 1 by root 2 of the value at origin. Everyone calculate omega c first. Later on we can see about fc, sir, analog. Fourier transform of this one is what? 1 plus e power minus j omega by 2. So the DC response of course becomes 1. 1 plus 1 by 2. If I take magnitude whole square here, sir, right side 1 by root 2 whole square is 1 by 2. What is the indirect meaning of magnitude whole square? H into H conjugation means 1 plus e power minus j omega c by 2 into 1 plus e power j omega c by equals to 1 by 2. 2 to jump cancellation. Numerator becomes what, sir? 2 plus 2 cos omega c by 2. 1 into 1 e power minus j theta into e power j theta. 1 plus 1 becomes 2. 2 cos. Further enjoyment. 1 plus cos omega c is 1. Cos omega c 0 means omega c becomes pi by 2. 3 pi by 2 also you can take, but digital frequency limited for what range? Less than pi. 3 pi by 2, 5 pi by 2, they are also correct, sir. Digital frequency limited for the range less than. What is there, bacha? Omega c is 2 pi fc by Fs. Omega c we got pi by 2, sir. Omega c we got pi by 2 equals to 2 pi into Fc by Fs is 9 kilo. Solve for Fc 9 by 4 kilohertz. It is asked for find the analog cutoff 3 dB. Okay. First solve for a digital frequency. Later on you do normalization 2 pi f by fs. 2 pi f by fs. Okay. Whatever the comparisons I have given in this chapter, take a white paper and note down. Later on, not now. And regularly practice that properties. You must habituate to properties in signals. How to convert one property to another property. You must be careful, sir. How to convert one property to another property. Okay. Whatever the disadvantages CTFT is having, same disadvantages are continued by DTFT also, discrete time Fourier transform also. Listen the introduction which I am giving for next 20-25 minutes carefully. Like CTFT replaced as Laplace, DTFT is replaced as jet transform. Instead of CTFT we use Laplace. Instead of DTFT we are using jet transform. In this chapter DTFT we discussed A power n un spectrum under the condition mod A less than 1. If A is greater than 1 it is unbounded signal, sir. No Fourier. If A is greater than 1 it is unbounded signal. Another disadvantage is we have not solved more than second order difference equation. Hardly we solved second order only. If you have third order and fourth order difference equation, how to get solution means DTFT is difficult. Jet transform becomes easy. So, like the problems of CTFT are suppressed by Laplace, the problems of DTFT are suppressed by jet transform. Some fellows will say for style, the G transform, instead of jet transform, they will say G transform. Maybe they are watching regularly GTV. Okay. How to give definition of jet transform? Listen everyone. One way generalization of DTFT. That is one way. Another way, discrete counterpart of Laplace. Discrete counterpart of Laplace transform is jet transform. In Laplace, we learned ROC, causality, stability, all that concepts again we are repeating now in jet domain. Okay? In ROC, we have learned causality, stability using Laplace there. Same concepts now we are discussing for discrete signals, sir. Listen. What is the need of jet transform when you have Laplace already is, we know analog systems are designed in Laplace domain. Suppose you have taken this RC network where you are writing transfer function as 1 by 1 plus SRC. If resistance is not a fixed value, transfer function is continuously fluctuating. Generally, we say resistance with certain tolerance, 2% or 3% tolerance. Sir. As long as resistance is not fixed, respect to transfer function is also not fixed. Even you apply fixed input, output is fluctuating. Even you apply fixed input, output is fluctuating. So the main problem with analog systems is component variations, temperature effect, humidity, temperature effect. Most of you know the word thermistor, temperature dependency. So after some years, if any analog component is gone, you may not get the required output. For that reason, we are using a new storage element, delay. You store the value today, you observe after 10 days, no change in the answer. But it is not the case with analog component. We know any delay element is shift register, combination of flip-flops. So our target is convert the analog components to discrete or digital. Convert the analog components to discrete or digital, mathematically Laplace transform to Z transform. Mathematically Laplace transform to Z transform. Okay. Why I am saying discrete counterpart of Laplace is Z? Listen here. When we started the chapter Laplace, we said input e power st. Input is e power st, where s is a complex variable given by sigma plus j omega. Now onwards, analog frequency, I am using the symbol ohm. Analog frequency is ohm. We have written the output as e power st into h of s. In a similar way, if you take input at z power n, where z is a complex variable given by r e power j omega, the output becomes z power n into hz. Their eigenfunction logic is e power st into h of s. Now eigenfunction logic is what, sir? Z power n into h of z. The relation between the two complex variables z and s is z equals to e power sts. For every s plane pole and 0, for every s plane pole and 0, corresponding z plane pole and 0 is obtained by this relation z equals to e power s into ts. Listen, how you got that? Listen, sir. xt equals to e power st means what is the discrete form of that one, sir? E power s and ts, which now we have written as z power n. By comparison, you can feel that z equals to e power sts or not. For every s plane pole 0, corresponding z plane pole 0 is decided by this relation z equals to e power s into ts. In the process of converting analog system to discrete or digital system, mathematically we require this relation. Mathematically we require. So in general, Z transform of a signal x of n is defined as xz equals to sigma minus infinity to infinity x of n z power minus n. X of n z power. But what is z value here, sir? A complex variable given by r e power. If I substitute, what will happen on the right side? Sigma minus infinity to infinity x of n r power minus n e power minus j omega n. How I can link this z transform in terms of DTFT, sir? In DTFT, r power minus n is missing. So z transform in terms of DTFT is Fourier transform of xn into r power minus n. Z transform in terms of DTFT is Fourier transform of xn into r power minus n. But what is a similar type of formula we studied there? In Laplace, how we expressed it? In terms of Fourier transform, everyone recollects, sir? We said Fourier transform of x of t multiplied by e power minus sigma t. Fourier transform of xt multiplied by e power. There, what multiplier has made difference for us in Laplace? Everyone see the cursor. E power minus sigma t. Now, what multiplier makes the difference for us? R power minus 1. See here. Suppose if I make R as 1, automatically Z transform DTFT definitions are same. If I substitute R place 1, Z transform DTFT are same. But in Laplace, are sigma place 0. Listen. When R equals to 1, Z transform and DTFT both are equal. What is the meaning of R is 1 in the Z plane? unit circle, radius 1, unit circle, radius equals to 1, that is called as unit circle. But what we said, there sir, when sigma is 0, S equals to J ohm, that is Laplace and Fourier definitions are equal. Laplace and Fourier definitions are there. We mentioned in the S plane, there we mentioned in the S plane, on the imaginary axis, Laplace and Fourier definitions are equal. Now what we are saying, sir, on the unit circle, jet transform and DTFT both are same. This is jet plane. This is jet plane. What is the another range of analog frequency that is varied, sir? Minus infinity to plus infinity. But what is the range of digital frequency varied? Upper half of the circle 0 to pi, lower half of the circle minus pi to 0, clockwise, anti-clockwise direction. Upper half of the circle 0 to pi, lower half of the circle minus pi to 0. In the process of converting S plane to jet plane by using this relation Z equals to e power STS, in the process of converting S plane to jet plane by using that relation, sir, what type of mapping is done is entire positive part of J ohm axis must be mapped along the upper half of the circle. Entire positive part of J ohm axis must be mapped along the upper half, whereas negative part of J ohm axis corresponds to lower half of the circle. Negative part of J ohm axis corresponds to lower half of the circle. For performing this mapping, what is that mathematical relation we are going to use, sir? For performing this mapping, Z equals to e power STS. By using this relation, we are doing that mapping. Applications of jet transform are applications of learning this topic. All the digital filters are designed by using jet transform. I am giving some examples like audio equalizers. When I am discussing the property, I will tell you application. Certain digital filters are designed by using jet transform. It is also used in sample data control system. Normal analog control system, how you are checking stability, Routh-Hurwitz criteria, Bode plot, Nyquist plot. But here we are learning new techniques like Jury's test, Lyapunov test, like that. That is advanced control system, digital control subject. To check the stability, we require new techniques, sir. Jury's steps, Lyapunov test, like that. So Laplace calculated on the j omega axis Fourier. Similar way, jet transform calculated on the unit circle is DTFT. Jet transform calculated on the unit circle. Lesson. How we discussed the ROC concept there in Laplace, region of convergence. Some formula we selected like this. Integral modulus of xt e power minus sigma t dt less than infinity. Integral of mod xt e power minus sigma t dt less than. In the jet transform, how this condition changes, sir? If you take modulus to the definition of jet transform, what will happen? Take magnitude to the definition. Take modulus. Right side magnitude of e power minus j theta is 1 or not? See the cursor. Magnitude of e power minus j theta is 1. Such that that condition becomes what? Sigma mod xn r power xn less than infinity. Sigma mod xn r power minus n. Any signal is failing this condition means you cannot take jet transform. Like we discussed in Laplace, right-sided, left-sided signal. Here also the concept will repeat, sir. Here also the concept will repeat. That is the reason this second statement is given. Discrete counterpart of Laplace is Z. Whatever the enjoyment we have done in Laplace, we are continuing the same enjoyment here also, but for discrete signals. Okay. So what multiplier that will make difference for this chapter, sir? R power minus n. If the original signal is unstable signal, it may be modified to stable signal because of R power minus n. What multiplier that has made difference in Laplace, sir? Which multiplier has made difference? E power minus sigma t has made difference there. E power minus sigma t. Now what is making difference for us? R power. When we checked stability, there our enjoyment went on with which axis? J omega axis. Now our enjoyment will go with what? Unit circle. When we are checking stability, we are taking which as reference, sir? Unit circle. There we have taken which as reference? J omega axis. Okay. With the two simple relations, we are going to conclude today's topic with two simple relations. Everyone recollect? With respect to ROC in Laplace, right-sided signal means what is a multiplier we said. Everyone respond. Right side signal means what is a multiplier we have taken in Laplace, sir? UT. Left side signal means what we have multiplied. Left side signal means what we are multiplying. Minus U of minus T or not. Right side signal multiplier UT. Left side signal multiplier is minus U of minus T. A similar concept again is repeated here. A similar concept is repeated in the jet plane. Observe here. If you take a discrete signal like A power n un, if you take a discrete signal like A power n un, multiplied by un indicates it covers positive index or not. Multiplied by un indicates it covers positive index. No condition on A, sir. If mod A less than 1, it is going to act like decaying type. If mod A is greater than 1, it is going to act like growing exponential. Mod A, any value of A you can choose, because what multiplier now makes difference for us? R power minus n makes the difference, sir. R power. When you want to calculate the jet transform of this one, range of summation, that is where it is sigma 0 to infinity signal A power n multiplied by jet power minus n, sir. Further enjoyment 0 to infinity A jet inverse whole power n. That is nothing but 1 plus A jet inverse plus A jet inverse whole square, etc. That can be written as first term by 1 minus common ratio under the condition common ratio less than 1 means mod A by mod z less than 1, from which we can say mod z greater than mod A. As z is R e power j omega, what is the meaning of mod z, sir? A circle of radius R. A circle of radius R. This is ROC. In Laplace, what is ROC we have chosen, sir? Sigma real part of S. Sigma real part of S. But now ROC changes to which term? Mod Z. ROC changes to mod Z. It means you can say A power n un sequence is having jet transform as A power n un sequence is having jet transform as 1 by 1 minus A z inverse or z by z minus A under the condition mod z greater than mod A. Everyone see here how this is shown in the jet plane. How this is shown in the jet plane is we have a 0 at 0, pole at A. Draw a circle of radius A. Draw a circle of radius A. Unit circle is reference for stability. Unit circle is reference for stability, sir. I am assuming A value less than 1, maybe greater also. Like we studied, ROC should not contain any pole. That property remains same here also, sir. ROC should not contain any pole. Jet place substitute A by 0 is infinity or not? ROC should not contain any pole. But the other property we stated in Laplace is ROC of Laplace consists of lines parallel to j omega. Here ROC of jet transform consists of different circles of different radius. ROC of jet transform consists of different circles of different radius. What is the shaded portion? Now we have to choose that 1 by 1 minus A Z inverse is convergible for what region? Any value from A to infinity. Mod Z greater than mod A means any value from A to infinity. Everyone see the left side graph of your left side part. A power n un is a right sided signal or left sided signal? Come on friends. A power n un is right sided signal or left sided signal? Tell me. Right sided sequence. Where you got the ROC? Outside or inside? You got the ROC as outside or inside, sir? Outside. Whenever you take a right sided signal, the respect to ROC in the jet plane is what? Outside the circle. Whenever you take a left sided sequence, the respect to ROC becomes inside the circle. How we studied this point in Laplace, sir? Right side signal means right of the rightmost pole. Right side signal means right of the rightmost pole. Instead of right of the rightmost, what is the word now? Outside. Left side signal means left of the leftmost. Instead of left of the leftmost, what is the word now? Inside. In jet transform, when you are dealing ROC, never forget the word mod Z. Magnitude of the pole. If you say jet greater than something, less than something, gone. Just go through the steps, everyone, sir. Outline. Go through the steps once. A power n un sequence is having jet transform as 1 by 1 minus A Z inverse. 1 by 1 minus A Z inverse. Mod Z greater than mod A is the ROC. Mod Z greater than mod A. ROC should not contain any pole. That property remains same. But instead of lines parallel to j omega axis, what is the enjoyment now? Instead of lines parallel to j omega axis, sir, what is the change? ROC of jet transform consists of different circles of different radius. ROC of jet transform consists of different circles of different radius. A may be complex also, but magnitude of the pole only we are taking. 2 plus J3 whole power n means take magnitude and draw the circle. 2 plus J3 whole power n also no problem. We are sketching the circle with its magnitude or not. Mod Z. From this relation, what is the jet transform of un we can take, sir? Directly A plus 1. Directly A plus 1. What is the jet transform of un? 1 by 1 minus Z inverse. A plus 1, sir. 1 by 1 minus Z inverse. Jet transform of un is 1 by 1 minus Z inverse. This is a right-sided sequence. This is a right-sided. In a similar way, suppose we have chosen left-sided sequence minus A power n u minus n minus 1. Because I multiplied by u minus n minus 1, it has to stop at minus 1. It has to stop at. Based on the value of A, you are retaining that graph. Based on the value of A, sir. Why we are stopping at minus 1? Because first signal has covered from 0 to infinity. What is opposite in discrete? Try to stop at minus 1. Try to stop at minus 1. That is a left-sided sequence. Outside the circle with largest pole in magnitude, not unit circle. Whatever the number A you are taking outside that circle, unit circle is for stability. If A is 2, outside the circle of radius 2. If A is 1 by 2, outside 1 by 2, sir. Okay? Listen. What is the jet transform now for this is vary summation from minus infinity to minus 1. Signal is minus A power n, Z power minus n. Vary summation from minus infinity to minus 1. For solving this summation, I am making one modification, minus n with a variable m. Because sum of infinite terms positive side we know formula. So further enjoyment is what? When you take minus n as m infinity to 1, a power minus m z power m infinity to 1. As this is addition, 1 to infinity or infinity to 1 meaning is same, sir. 1 to infinity or infinity to a inverse z whole power m. A inverse z whole power. So what is the series expansion? A inverse z is the first term, m plus 1. A inverse z whole square, etc. First term by 1 minus common ratio. First term by 1 minus common ratio less than 1. Further it is simplified as mod z less than mod a. Further it is simplified as mod z less than mod a. Z by a internally, sir. It is z by a internally mod z less than. If you multiply both numerator and denominator with z, it will look like our previous formula only. Multiply by first a minus z by a minus z means z by z minus a. Same as our previous formula. Same as our, only the ROC differs, sir. So how this is shown in the jet plane? How this can be shown in the jet plane, sir? We have a 0 at 0 pole at A. Draw a circle of radius A. But where is the shaded portion? Don't include the pole. ROC lies inside the circle. Don't include the pole. ROC lies inside the circle. Our signal is left-sided. ROC is inside or not? Our signal is left-sided. ROC is inside or not? Respond. Minus a power n u minus n minus 1 also has the same transform. A power n un, what is the transform? Z by z minus a. A power n un is z by z minus a. Minus a power n u minus n minus 1 is also having which transform? Z by. With these two formulas, we are studying this entire chapter. Everyone tell me one more time. Laplace and Z transform. For a right-sided signal, what is the multiplier we said in Laplace? U of t. Now what is the multiplier from our previous slide? Un. 1 by 1 minus a z inverse or z by z minus a standard forms are. Their ut multiplier here becomes un. For a left-sided signal, what is the multiplier? For a left-sided signal, minus u of minus t. But what is the change now, sir? Minus u of minus n minus 1. There minus u of minus t, now it becomes minus u of minus n minus 1. Remember that sufficient. Remember that sufficient. I don't know how many of you really remembered our introduction classes. Introduction classes, we said ut plus u minus t equals to constant for all time, 1 for all time. Discrete case, what is the change, sir? Un plus u minus n minus 1 is 1 for all n. We got equivalent formula or not? Ut equivalent like un, u minus t equivalent like u minus n minus 1. Come on, friends. We got equivalent formula or not? That is the reason I mentioned with you, study the first chapter carefully. Even today's class also we are using that logic. Ut corresponds to un, minus u of minus t corresponds to minus u of minus n. Only with this formula our entire discussion will go. Z trans means 1 by 1 minus a z inverse or z by z minus a. First you write a power n. If you feel right-sided, un multiplied. If you feel left-sided, sir, what is the multiplier? Minus u of minus n minus 1. Okay? That's all for today. I am getting throat pain. Continuously I am speaking now. That's all for today. Tomorrow you can meet sharp 5 o'clock. Tomorrow you can meet sharp 5 o'clock. Doubts also for few members I can explain today. Because today I have done more shouting in the explanation. Center small circle. अरे बच्चा वो zero small circle नहीं है. Zeros are denoted. Zero poles also you don't know how to denote. Zero is located like that. For visibility I have taken thoda big. Zero, location of zero. Yes. Only 5 members I am giving chance today. Rest of them don't ask me. Only 5 members. Bolo.
Audible, sir.
Yes.
Page number 15.
Tell me.
So here we get angle is -2 omega plus pi by 2. Okay. If we proceed by regular method, in second we get -2 omega minus pi by 2.
How will get minus pi by 2? J only will get pi by 2 only. Solve karo. अच्छा सा solve karo. Somewhere you have done mistake.
I mean, anyhow, this relation must be satisfied for all values in that question, no?
I have solved already. Yeah, I know pi by 2 will be there. You just solve it. You will know.
Okay.
एक बार try करो. Somewhere you have done mistake.
Okay. Thank you, sir.
Yes.
Hello, sir.
Yes, ma.
Sir, page number 21F. Sir, I just wanted to know the frequency range for the digital filter pi by 4 and pi by 2. That is a stop band frequency range, right, sir?
No. Continuous signal. Some continuous signal we selected with highest frequency 20K. In that, it is stopping 5 to 10K, ma.
Yes,
So
sir.
that fellow is asking with when the highest frequency is like this, with what sampling rate the respective digital frequencies can be stopped. So to convert analog to digital, this is the formula 2 pi f by fs. Highest frequency 20K means sampling rate 40K. Normalization we have to do 2 pi into 5 by 40. 2 pi f by fs is our formula, na? 2 pi into 5 by 40. This side 2 pi into 10 by 40. So if continuous signal is stopping 5K to 10K, equivalent digital system is stopping which frequency? Pi by 4 to pi by 2. As that fellow has mentioned ideal, if you want, you can draw the characteristics. What is there? Pi by 4 to pi by 2, both sides you have to stop. Like this.
Okay, sir. That's what I am asking, sir.
Okay.
Got it, sir. Thank you, sir.
Right. Yes. Hello.
Sir, could you open 27F, sir? Sir, here, sir, I could not get, means like in the range that you told, no, that inside the circuit, but excluding the pole. How so?
ROC should not contain any pole, na. Z by Z minus A. Z plus A substitute karo, A by 0 infinity hota hai na.
Okay, because of that. Okay, sir.
In Laplace also we discussed now. It is not a new point here.
Okay, okay. Thank you, sir.
Hello,
Yes.
sir.
Sir.
Sir, for linear phase system, like we studied that for if symmetric, it will be minus alpha omega. For antisymmetric, it will be minus alpha omega plus beta. Sir, I did not understand the beta part. Like what we will
For odd signal, already earlier what we studied, for any odd signal, generally what is the phase angle added?
pi by plus or minus pi by 2.
That is only added here. If you have plus j plus pi by 2, if you have minus j minus pi by 2 will be added. In all problems we solved plus j we got. So pi by 2 is added.
Okay. That's it only. Okay, understood.
Hello, sir.
Hmm.
Sir, in this slide, last slide, sir, is this circle is inside unit circle, sir?
Which circle?
Sir, here
Can be
you have,
anywhere. Who stopped you? A can be any number.
it may be inside or outside the unit circle, sir.
I have not discussed any stability there. With A formula only I discussed. Then anti-causality, stability, causality. That is a different story. Unit circle is always reference for checking stability. A may be any number here. Previous formula, this formula, A may be any number.
Sir, in previous slide, you have drawn unit circle, sir. That's
Roughly I have drawn. Why I have drawn unit circle? I assumed A less than 1. I can take A greater than 1 also. I mentioned that point. I assumed A value less than 1. Here also you can draw here, no problem. You can draw circle, unit circle, no problem. Draw curve.
Okay, sir. Based on stability and wave value.
Only for stability we require that unit circle.
Okay, sir. That was my doubt, sir.
Chalo.
Thank you, sir.
Sir, sir, can you just give screenshot of first 3 pages?
Anyway, they will send in few minutes now.
Okay, immediately they send.
Array, you are not seeing they are uploading regularly.
No, I write that on the spot, so I don't see that.
What you are saying?
Whatever you write, I write on the spot only.
देखो पहले वाला एक
There was no light, no sir. So.
पहले वाला हो गया एक.
Yeah, sir. You sir click on it. I have started recorder. You just go on.
2
3
3
Yes, done. And 9 and 10.
Oh,
9 and 10.
You want multiple enjoyment? 9 10.
Okay, done, sir. Thank you, sir.
Right, enjoy.
Thank you, sir. Bye. Good day.
Hello, sir. 15F, sir.
Yes, ma'am.
Sir, I'm not getting pi by 2 by doing with original method, sir. By doing.
You will get j ma, extra 2j will be there. You take common multipliers. Why you will not get everything? I will not get.
Sir, I'm getting only omega. I mean, in terms of omega only, I got it.
Listen. In the 7th slide, I have shown how we got what is h power j omega answer. We got 2j sin omega by 2 exponential. We have phase angle here and j will create 90. Like that, there also you will get.
Okay, sir.
Solve it properly. You try ma. Definitely you will get. Otherwise, for fun, I will discuss.
Okay, sir.
It will be there. You just solve
I'll try,
it.
sir.
Okay. Very
Sir.
good.
Okay. Thank you.